Hello, dear guests. I'm very happy to welcome you in the next Unicorn University Open. And I'm very glad to welcome here my colleague Marek Šťastný, who will be helping me to guide you through the conference. Actually, the conference has a very nice topic, which is artificial intelligence. And as you probably know, usual conferences of Unicorn University Open have several parallel streams of simultaneous translation into Czech and English, where you can choose your language of your preference. But today, I heard, Marek, that we have another stream.
Yes, there is surprise. Since this event is dedicated to AI, we have there another additional stream completely translated and powered by AI.
Okay, so you can check it by yourself, whether it works properly, or you can watch your stream of your language and then look for the text, whether it fits what we are saying. Well, I mean, the topic of the conference is very wide, right? Because artificial intelligence, everybody is speaking about that. Everybody makes predictions, and everybody is speaking about future or threats, about technical as well as ethical questions. I don't know, Marek, what do you personally like on AI? I mean, what is your favorite field?
You know, you said it already because AI is mostly about predictions. So I expect that the guys from Gartner will show us the famous hype cycle for AI.
Okay, but before we invite him into the field as a first speaker, let me just recap what we can expect today. There is a very intensive program, so be on time where you can see the presentation. The first speaker will be Lukáš Erben from Gartner and Inside IT, who will be introducing some predictions and talking about future and trends. Then, immediately, Romportl will speak about some risks and threats. So we will maybe going against the first presentation, we'll see. Then the second part of the morning lectures will be starting with Jiří from Škoda Auto University, who will be speaking about the application of AI into a very important field here in Czech Republic, especially, which is automotive. So how we can use artificial neural network in automotive. And then Mr. Josef Nový will be speaking about deep learning and practical applications and whether we need math to do this. So from simple to complicated tasks. So very technical problem, very technical perspective. And then we switch to ethics and sociological problems with David Černý, a philosopher who will be speaking about ethics and ethical questions. So that will be morning program. And we skip to afternoon program or after lunch program, which is started by Josef Šlerka from Charles University, who will be speaking about prompt engineering. So if you're interested in how ChatGPT and other things are working, he will introduce the basic core problems and technologies inside. Then Jaromír Šivic will be speaking about AI and its application to a very important field again, not automotive this time, but energy. So another very perspective and very intensive field. And second part of afternoon will be started by my colleague Marek Šťastný with his or our colleague Filip Zoubek from Unicorn, who will be speaking about artificial intelligence in cybersecurity. Again, very important topic. And then we somehow summarize things and say, well, can we take the artificial intelligence, can we take the machine learning and use it as a service? So can we just jump into a particular website and use it without previous knowledge? And Jakub Kúdela from Microsoft will be speaking about this opportunity and possibility. And in the end, of course, we will be speaking about how to teach machine learning and artificial intelligence. So our colleague Karel Šafr from Unicorn University will describe the process of teaching AI somehow efficiently. So that's the program. And let's skip for some basic description of today's program. So I will ask for next slide. And of course, after each lecture, you are asked to pose questions because we have some limited time to ask. So here you can have a QR code, or you can find it on the website, and you can ask as many questions as you can. Of course, we have just limited time, so we can ask several of them, but we will try to answer most of them with our colleagues or with our speakers. So do not hesitate to ask anything you are interested in. And of course, we have today, same as before, prepared some prizes for you. So every time before the break, I will notify you to answer some similar questionnaire where you can answer several questions and you can win some prizes after the next block. I will always notify, so you don't need to remember now or going to this QR code at the moment. Okay, and in the end, we will ask you for providing a feedback for the conference because we wanted to improve the conference for the next time. So please follow the QR code either now or maybe in the end of the conference and provide the feedback. We also give some prizes, so 10 of you who will provide some feedback, whatever type of feedback, will be given 10 online courses from our partner, Unicorn Publishing and Red Monster. Okay, so that's all the formalities because we need to move. And as my colleague said, we need predictions. We need to see what is future. So I guess probably the best way is to ask someone from Gartner. And we have a special guest here. So Lukáš Erben from Gartner and Inside IT will be speaking about the future. So the floor is yours.
Thank you for having me today. Well, we have been prepared by many sci-fi authors in past for this, from Karel and his RUR through Arthur C. Clarke and his 2001. We've been prepared that AI will eventually come and will help us, but maybe also will threaten us. And threatening us is something we maybe start thinking first when we learn that it's very capable. And that's what we started with in last year. My colleagues at Gartner started with. And they thought, okay, so we are doing those predictions. Can AI already match us? And can it eventually replace us? And they played already with the old model, with GPT-2, and tried to ask AI to do some predictions on AI, of course. And what happened was that they made a set of 3 predictions by AI and 3 predictions by analysts and spot the difference, spot the false ones. Well, you may spot the false ones on the top right. The automation is something that wouldn't go through the final proofreading probably at Gartner. But at the bottom right corner, there is something that might sound feasible and probable. So if you look at it, the red ones, those are the fake ones. The white ones are the actual ones. And it will be interesting whether some of the fake ones will be actually fulfilled and more precise than the real ones. So, what we'll talk about today, we'll talk about the hype, about the elephant in the room, which is of course ChatGPT and generative AI, and about the reality of generative AI versus the hype. I'll talk a bit about the workers and AI at work, because Gartner looks at what are companies actually doing with the AI, how are they implementing it, how are they planning to use it, or what have they already done. Then we look at how easy it will be actually, and it already is to buy or make AI. What will it be good in a couple of years, and where we stand now, what the companies are really doing, and what have they done in implementing and using, and what are the challenges that they are facing. So let's look at the elephant first. Gartner did a prediction last year saying more than 30% of the new drugs and materials will be systematically discovered using generative AI techniques. Now, think about it. This says about the drugs and materials. It doesn't say about a thesis for a bachelor's work or posts for social networks. So this is what we have been talking about a lot before the hype around the generative AI, be it the Journey or the ChatGPT came. And why that hype came and why it's so strong? Of course, because people have spotted it and found out it's really good and it's really useful, and started using it so fast that it broke all the records. It took 24 months Twitter to get first million users. It took Spotify 5 months, and it took ChatGPT 5 days to get first million users. So the hype is understandable. And Gartner has something that talks a lot about hype. It's called hype cycle, and it's based on Roy Amara's law. Roy Amara was a futurist. And he said in his law, or in his observation, that we tend to overestimate the impact of the new technologies and technological advancements in the short term, and we tend to underestimate it in the long term. And that's what hype cycle is about. It shows you where are the various technologies, in this case, the various technologies related to AI, from perspective of hype and maturity. And as you can see, this is from last year, from summer of 2022. Generative AI was just entering the peak of the hype, and analysts expected back then that it will take 2 to 5 years to come to that mature phase. Now, we are maybe accelerating at faster pace than that now. And just to explain you how the hype cycle combines the hype and maturity, the first half of the cycle is the hype, is that we overestimate. The second half is the maturity. And there are a lot of ways you can look at hype. You can look at what are the opportunities from supplier perspective or vendor perspective, what are the opportunities from user perspective, where you maybe start hiring people for that. You can look at it in a very simple way, the image on the right here, what we could be using, maybe, but it's risky, and on the left half of the cycle. And on the right half, why aren't we using this? And is it deliberate decisions that we skip that and haven't invested in that? So think about AI as about and especially generative AI as about a hype issue. Now let's try to look through that hype. Gartner has many useful visuals. One of them is use case prism, which tells you how various technologies are actually in reality being used, implemented, or developed in various areas or industries. So for generative AI, of course, at the top of the use case prism, where you have greatest business value and highest feasibility, you have these things that the ChatGPT or Midjourney do. But there are many other things that might have a huge impact and might be really revolutionary for society, like the drug design and the material design, but are not so easy to do, and therefore there isn't so much hype about them. You can look at it also as a matrix across various industries and what may be used where. You can see that, for example, synthetic data is the area of generative AI that might be used across most industries. Now, if we look at what was happening in the venture capital world before the AI hype came, before the ChatGPT hype came last year, there have been a lot of investments in many various areas. And between 2019 and third quarter of 2022, last year, total in venture capital investments in generative AI were about $1.7 billion. Now then came ChatGPT, and after a few weeks, months, Microsoft basically decided to pour into OpenAI $10 billion. So more than 5 times the total amount of investments over previous more than 2 years. So this really also changed a lot of things and accelerated the developments quite a bit. So how these accelerated developments will project into areas that are most relevant to most of us, that's work. And to how should we look at AI as a worker. Gartner prediction, again from the last year, says that by 2025, almost a third of outbound marketing messages done by large organizations will be generated by AI. Now, this might come probably even sooner than that, looking at what's happening with generative AI. We will be seeing a lot of troubles coming from this, from using AI, because one of the biggest issues, of course, we are finding with the large models is that they create something that looks very convincing, but that might be full of errors. And error is something we have big problem to allowing AI to do. Let me give you an example with autonomous cars. How many accidents are there? How many deaths are there on the roads every year caused by drivers? And these are acceptable for us. But will we be able to accept just 1% of those accidents and deaths if they are caused by autonomous vehicles and by AI? And this projects to many other areas, even to those marketing messages, of course. So one of the biggest problems will be when we start really using AI officially in businesses, will we be able to tolerate its mistakes or not? Will we have trust? Will we be able to have it transparent enough to know why those mistakes have happened, for example? So this was one of the biggest challenges that will come. And of course, the future of working with AI might be bad and might be good. A bad future is having the worst assistant or even boss that you can imagine, that gives you assistant gives you thousands of alerts, that demands updates at hourly basis, and really makes you into crazy mouse in a workplace. On the other hand, it might be the ideal work pal that makes your work easy, fun, makes you much more productive. That really replaces maybe your superior when he goes on a paid leave, in a way that he reminds you of your tasks kindly and helps you to keep on track. In fact, this will be something in between. There will be some good aspects and some bad aspects, but don't expect the AI to only improve our lives and work. And I think there will be more warnings coming from other speakers today after my session. How are workers actually looking at AI? This is from a survey that was conducted already in 2021 among 1,500 respondents by Gartner. And it shows that about a quarter of people are not very happy about vision or onset of AI. They are averse, they are not really welcoming these changes and new technologies. Maybe they are even those who still read ordinary books, like me. But about a quarter or more than a quarter of people are friendly, are very positively looking forward to having a chance to increase productivity, have some work really accelerated and eased. And about half of them were conditional. Depends on what it will bring me. Will it threaten me in the work, or will it help me? Of course, this might change, and this has probably changed after many people had those first experiences with ChatGPT and other AI tools that are publicly available today. Some may have gotten happier and more excited, and some may have gotten more threatened. Maybe that scare was the first reaction in most cases. I am done. I will be replaced within a couple of years, and what will I do? But let's look at it also positively. The AI will infuse every aspect of work of us, technologists and executives and knowledge workers, and it will change a lot. And it's upon us and upon our leaders in businesses whether it will be more positive or more negative change. One of the reasons why this change is happening and will be happening is because it will be much easier to buy or make AI in the future. Gartner expects, and again, this is last year's prediction, that by 2025, half of the companies that are implementing, will be implementing some AI orchestration platforms, meaning they will use and combine various types of AI, being proprietary offerings and also, for example, open source, to create even better solutions. And there are other areas that will be helping that. Lower data barriers, for example. Having data for training has been a huge issue in the past, but may not be anymore in the future, because synthetic data generated by the generative AI will be helping. Companies may be looking at different ways of training using data that are relevant to their use case, and it might be different type of data, not just the big one. And there will be other approaches like sharing, marketplaces, brokerages. Of course, I already mentioned the proprietary solutions and open source foundation models, and there is already quite a wide offering in the market. This is just a current overview of the more significant ones. So a lot of things can be done with this, and I'm hearing from the market that actually companies are experimenting, especially with those open source foundation models, trying to develop their own solutions and buying the powerful GPUs or systems that they can use to train and experiment. Surprisingly, another area where organizations feel that this might not be so difficult is talent. And that might sound very strange, because in IT, talent is always a problem. But with AI, it might be somewhat different. The thing is that the AI makes actually itself more accessible. It can help people train themselves to compose functions. It can help people to easily handle low-code or no-code approaches. So there is something that you can call citizen AI, actually the usage of the AI and implementation of AI from the user perspective in the companies might be easier than many might expect. And of course, this will have maybe some strange implications. Well, today, many companies have developed a number of chatbots, for example. And maybe in the future, when people get really good at these things, with the help of AI, they will develop their own chatbots to represent themselves. And you might get to a strange situations where chatbots will be calling chatbots. Those of you who are from Czech Republic might know the song by the country group called Dialog 2000, Dialog 2000, where two phone answering machines are calling each other and talking to each other. This is about 30 or 40 years old, maybe 50. And it's very much what's been already experimented, very much like what's been already experimented in recent time. For example, there were tests with Google Plex calling restaurants for bookings, for table availability. And in some cases, it called and talked to another chatbot. And the other chatbot tried to upsell him on a table. They were discussing. And you can even have different personalities of those chatbots. One can be, for example, rude American. The other may be polite English. And it makes really interesting situations. And these situations will roll out in the future in many forms and influence really how we live and how we do business. However, when you have less data, when you have fewer experts, citizen AI developers, this will be cheap, easy, and this will be risky. And that's the important thing to think about. So what will be good to AI in 3 to 5 years? And what might be bad about it? Well, last year, Gartner did predictions that by 2026, 5% of workers will routinely use AI against the wishes of their employer. I think this is already happening today. Maybe sometimes unknowingly, because many companies still haven't put some rules for using, for example, ChatGPT with company data or company content. But it's already happening today and will be happening in the future. This is because we'll be accelerating the ways we use AI. And of course, one of the ways how to do it is to basically just accelerate things you already do. Just to automate with AI the approaches that we have been already automating in past with other technologies. You can also innovate in automation area, and there might be some really interesting use cases. For example, imagine a company running an AI that monitors all the conversations of the employees for due diligence to actually evaluate how innovative the company is, how many good new ideas regarding the business are being developed in the company, and really projecting that into some reports and so on. Of course, some of these things might go wrong. AI may be interacting, doing chain reactions. And one such example might be, you might run, for example, a e-commerce site where you provide also space for other e-tailers. And you run two types of AI. One is monitoring what is being sold, what are the popular items, and basically recommends you what to start selling on your site. And the other is, for example, bidding in the supply chain. And imagine one of your partners that starts selling something, the AI notices it, informs the other AI that the AI in the supply chain overbids that particular partner, and you end up in the court because you have problems with monopoly power. And we mentioned people using AI against will of their employees, and one of the big topics will be bring your own AI. Will we allow it? I mean, we have allowed it with phones, we have allowed it with laptops, we have allowed it with cloud applications. We'll probably have to allow it to some extent with AI. But when you have one AI, you can control to some extent or know what it does. But when you combine more of them, you no longer have that ability to know what will happen out of that. So scaled AI that really will automate every aspect, but will also complicate things a bit. For instance, now, what are the companies doing now? Gartner expects that by 2025, 70% of new internally developed applications will have some AI or ML-based model incorporated. That's a lot, and it will really change a lot of things, but there will be many challenges. When we asked in 2019 CIOs whether when they will employ AI, 1/5 said that they have already done that. And including that 1/5, 4/5 said they will do it by 2022. When Gartner asked those CIOs again in 2022, only 1/3 say they actually employed AI. So there are still a lot of challenges. Data is one thing, and I have talked about it and why it might not be that much of a challenge anymore. Another challenge that might be harder to overcome is measuring AI value. It's like measuring the cybersecurity value. I mean, you either have it, you don't have it. If you don't have it, you don't know how valuable it would be until you are hacked. So with AI, it's in some ways similar. And of course, lack of staff. I was talking about how companies don't see it as a problem. They don't see it as a problem in the worker area. But if you want to build really something advanced, you need those top experts, and those are hard to come by. And another problem. Out of those 30% of companies that have already implemented AI, 40% indicate they have thousands of or hundreds of thousands of models deployed. That's crazy. That's really AI model sprawl. Can you do any control on that? This will be a challenge. AI is flooding those organizations who are using it, and the hardest thing in the future might be governance. And success will depend on it, and our future will depend on it. But I think that's for the next speaker more to talk about governance and safety of AI. This is all from me for now. Of course, time for questions, and I can recommend some Gartner webinars on AI that have been recently broadcast and are on demand, or it will be in the future.
Well, thank you, our first speaker, for a wonderful presentation. And we have several questions posted by our viewers. I may start with the first question.
I will try to answer to my best knowledge.
Yeah,
I'm more of a trend follower than AI expert.
Yeah, maybe I will start with relatively hard.
Okay.
No, I mean, there is if you think that the initial hype has been created by a financial speculation.
It has been not created, but it has been fueled.
Okay.
I mean, the hype is real and is relevant because whoever tried the ChatGPT was overwhelmed. Even though we find it makes mistakes, it hallucinates, it can go really weird in some situations. The huge investments that have been done have accelerated the release of the new models. We know that almost for sure, that there is a pressure from board members of Microsoft who are currently probably controlling OpenAI to great extent. And they are accelerating the release of new features, of the new versions and of the use cases. So it has accelerated.
Yeah, okay.
Okay, maybe let's get a little bit more visionary, because there is a huge added value behind AI and using of AI. So what do you think, what will be the, for example, in the next 5 or 10 years, the most valuable use case for using of AI, and how it will impact the society?
You are asking about 5 to 10 years, and honestly,
yes, exactly.
I saw some slides of the next speaker, and I think they will show you that it's really almost impossible to expect what will happen in 5 to 10 years from now, because things that we were expecting to come after 2040 or 2050 might be coming before 2030 in the AI area, and this might change the game again. I mean, 2 or 3 years ago, we were looking at generative AI. And there were investors who were convinced there is more opportunities in those materials or drugs areas, because there is a lot of money to be saved by generative AI, really. But then with the big language models and their abilities to really work in the knowledge economy, or to help in the knowledge economy, or maybe crash the knowledge economy, depends how you look at it, completely changed the situation.
Yes, it's clear that there is huge development behind it, and that it will evolve during the time. But on the other hand, still there are many use cases, and what is clear right now is that it definitely will impact the society.
What we don't know is what the regulation will be like.
Yeah.
US has started talking about regulations. EU has started talking about regulations. Italy has banned ChatGPT. So for reasons that are more related to, let's say, protection of the personal data. But the regulation might be also quite influential in what will happen and where the value of the AI will actually lie, because it may change that situation in the market.
Okay.
I have another question. I mean, to be precise, the viewer is asking what is the possibility of a chatbot to simulate his or her behavior on the social network, but maybe we can even generalize the question in sense of how do you view this future in social network when, you know, adopting AI and all these like special artificial intelligence people coming inside?
Well, it depends on how social networks will react to that. For example, I would see social networks like Twitter being more inclined to really make a perfect differentiate between who is actual user that is verified and who is some unknown persona, which might be actually human or which might not be human. Of course, again, you might have a verified human that will have a chatbot in the future pose for himself. So we are going into really funny and strange situations, and I think the social networks will change in many ways that might not be related to AI. For example, one thing analysts at Gartner are talking about is that in the future, the control of the data, of the personal data, will turn around, and actually people will start selling or offering their personal data to the social network in exchange for the services provided.
And so do you think that there could be the artificial person which become famous, but it's not a person at all?
Certainly, yeah.
I think that it is already happening.
It's
because,
already happening, I know.
But then there will be many issues, legal issues, like rights and
exactly. I know. I mean that you know, these people can earn a lot of money on the social network. So then, if you create an artificial person, then it depends on who is creating. And of course,
the question is also what will be the reaction of the public? Will people differentiate it between virtual persons and real persons? Will it be perceived in the same way by an audience? That's another question we don't have answer to right now.
But maybe the viewer is actually asking about the social hacking. So you're going to his or her account. And
this is a big issue already today, because you can really emulate voice, you can emulate the style of writing, and as the generative AI will get more capable and affordable and available, you may even emulate easily. You can do it now, but it's not that easy. A video of someone.
So maybe we are not here.
Maybe artificial intelligence.
I guess we are mostly out of time, so I think you were great opening the conference, and we will move to another topic.
Thank you.
Thank you. Which is the threats. As I said, we started with the future prospect, and we were talking a little about threats as well. But we have another guest of ours, which is Jan Romportl, an AI consultant, who will be speaking about all the threats that we can expect, probably how we should react to them. I'm not sure. I think it is threats important to handle, Marek.
We already discussed this because the governments are already trying to push the usage of the AI a little bit down and to postpone it and somehow avoid it. So it's clear that there is something bad, maybe something wrong behind it, and let's discuss this.
Okay. So.
Okay. Thank you for inviting me. Well, my goal here is to tell you about, well, not all the threats, not all the risks, but specifically about existential risks, which are the by far the worst risks that we, like the whole humanity, can face. It's basically the risks that can cause the destruction of the whole humanity, or the destruction of the long-term potential of the mankind. So, I'm like AI consultant working in the applied AI field, having like a startup in the field of cognitive protection of people. But my like kind of hobby in last 10 years was AI safety, and it always has been AI safety. And so it might seem to you that I'm a bit pessimistic and the talk is going to be pessimistic. I can only tell you it's like Madeleine Albright had. I'm an optimist who worries a lot. So from this perspective, yeah, you'll see it. And first, let's talk about what intelligence is. Like, forget all the psychological definitions of intelligence. They don't work. They don't tell you much. Like, intelligence is the ability to learn and blah blah blah. It's maybe useful in some contexts, but it doesn't tell you anything about the context of AI. So let's now consider intelligence to be an ability to achieve goals. And general intelligence, this is the important concept here. General intelligence is ability to achieve any goal. It means that a general intelligence system is a kind of general optimizer. It can find solution to virtually any loss function or virtually any reward function. And how we know that general intelligence is possible? We know that because we know at least one instance of general intelligence, and it's so-called human-level intelligence. It's something that your algorithm running on 80 billion single-cell organisms living in your head is actually doing. It's doing the algorithm of general intelligence. It means if humans were immortal and had like infinite resources, they would be able to achieve like virtually any goal. Well, maybe, fortunately, maybe, unfortunately, humans are mortal, which means that we cannot do that. But that doesn't mean we don't like work in the sense of the general intelligent algorithm. Well, what does it mean like achieve any goal? Like every living organism, like starting from a single cell, going through a snail, cat, everything, like to human and maybe something beyond human, maybe something which we don't know, performs one like universal task. It means that it performs algorithm that tries to model the world. Like humans have very complex algorithms for modeling the world. They run on our brain and on most of our body, basically. Like snails have like pretty simpler models of the world, and flies or insects, they have like very simple models of the world. But we all have models of the world, and the models of the world help you to predict what the world will be in, I don't know, in 1 second, 30 seconds, 1 minute, 1 day, one year. And basically, we as humans are rewarded through our dopamine reward mechanism by on the basis of how well we were able to predict what's going to happen in the world. And if we were good in that prediction, our like neural network gets rewarded by that reward mechanism, and we reinforce those trajectories that went, those decision-making algorithms, those decision-making parts that led to that reward event. And if it went wrong, then we just kind of try to decrease those trajectories. And what we also can do, we can act in the world. So if my model says, then in 1 second I touch my forehead like this, then basically like neuromotoric part of my body basically help that model. So it's like a dance where model is being continually updated through a process of reinforcement learning, and then I act to the world. I act in the world, and this is like the universal principle on which every living organism works. It's called predictive coding, and its author is like Professor Friston, and it's like a super cool like unifying theory for AI, cognitive sciences, neurosciences, psychiatry, everything. It's pretty cool. But why I'm saying this, it basically says that the reason why I am here, the reason why you're listening to this, the reason why the organizers organize that is that we all are trying to maximize our dopamine reward mechanism. And and this is the same reason why children are able to acquire like natural language capabilities. This is the reason why they learn how to walk. This is the reason why they learn to recognize human faces, why they recognize their mothers. Everything is basically is based on dopamine maximization. It's quite more complex than just dopamine maximization, but basically a reward maximization algorithm. So every living being has this like one universal goal, which is maximize the coherence between the world model and the world itself. and do anything it takes to maximize that coherence. It's done by a single cell, it's done by you, and you, as a byproduct of that, learned how to walk, learned natural language, went to elementary school, and then you ended up here, and who knows where else we will go. So basically, this is how general intelligence works, and you can see that on the way to that ultimate goal, which is the maximization of that reward, we come up with many other goals. Like really coming here, we want to come to the studio, then you just plan accordingly. You want to go to the college, then you have to do something. So you know that you create for yourself some of the goals. But how to see which goals you come up with based only on that reward mechanism, that's very opaque. That's very hard to track. And for example, you can see that a psychopath, like a crazy person who's gonna kill a lot of other people, has the same reward mechanism as an altruist who's been doing charity all her life. And they all have the very same reward mechanism. They all execute the same algorithm of general intelligence, but they end up with completely different values. And now this is something that I will basically, that I will base the rest of the talk on. So always keep in mind the difference of a human psychopath and a human altruist, both performing exactly the same algorithm, but ending up in completely different modes of behavior. Okay, and so what is artificial intelligence? It's a non-biological system that is capable of achieving goals when those goals are narrowly defined, like translate a sentence, park a car, recognize a picture, or make a targeted advertisement. It's called narrow AI, narrow artificial intelligence. It's a task, it's a system that can learn how to achieve a specific goal, play chess, recognize faces. And now the ultimate thing, artificial general intelligence, abbreviated as AGI, is a non-biological system that is capable of achieving any goal. So forget anything about humans, about modeling humans. AGI, the path to AGI isn't a path to mimic a model, a human intelligence. It's or to create anything around consciousness or a thinking machine. Well, it can be like a kind of collateral damage or collateral whatever. It can be like a byproduct of creating a universal optimizer, that the process, how the system optimizes, can be called thinking process, but that's definitely not the point. So it's very important to think of artificial general intelligence as a non-biological system that can achieve any goal. And if we just add a little thing, it can achieve any goal better than a human, then you might now start to feel why this is very important. So I repeat it. AGI is a non-biological system capable of achieving any goal better than human. And non-biological means that it hasn't been with us under the stress test of hundreds of thousands of years of biological evolution. That just means that most of the things that we meet in the world, from humans to other environmental factors, even to viruses, is basically mostly compatible with us because we've been with it in a close coupling for last hundreds or maybe hundreds of thousands or maybe millions of years. So non-biological means that it doesn't have this kind of proof of stability. And the point is, it's quite likely that the first AGI will be created already in this decade. It will be one of the greatest breakthroughs in human history. When people tell you it's going to be like electricity, forget that. This metaphor is paling against. It's going to be like a creation or appearance of natural language. This is like the biggest turning point in the development of Homo sapiens. So it's not electricity, it's like when human language was evolved. I don't have too much time to discuss this, but I don't know, I can then maybe forward to some literature on that. It means that there will be a general optimizer similar to human level intelligence, but it will not be limited by biological limits of human intelligence. In other words, every human psychopath has a big advantage that he's mortal. Like every crazy dictator will die one day. And another advantage of humans concerning societal stability and safety is that their ability to coordinate with other humans is very limited. It's by the means kind of pneumomechanic transmission of serialized signal, like super slow. So as a little spoiler, AGI will not have those two aspects. It will probably not die, and its ability to coordinate across huge groups of maybe instances of itself or maybe other humans is absolutely unprecedented. It means that it brings like a very destabilizing aspect to otherwise quite stable product of biological evolution. Now, when is AGI coming? Well, whenever I want to see any prediction, then sometimes I go to some like consulting group predictions, but more often I go to prediction markets because they're like more tractable, more precise. It's like the most efficient super forecasting mechanisms out there. One of them is Metaculus. I recommend you to, if you want to know something about the uncertain future, like a probabilistic forecast on anything you can think of, then go to Metaculus and try to search the question there. There's one quite popular question, date when weekly artificial general intelligence is publicly known. What this weekly means, it's a kind of, let's call it like proof of concept. It's not the like super intelligent AGI yet, but if that is achieved, like the weekly AGI, it's a kind of proof of concept that is possible. So when we looked at those prediction markets back in February 2020, you can see it here on the slide that the community prediction, aggregated median community prediction, was the year 2057. 2057, yeah. The median prediction means that half of the people think it's going to be sooner, half of the people think it's going to be later. Then when we looked 1 year later, in December 2021, the community prediction was 2043. So it was like already in like less than 2 years, it was already 14 years closer to us. What happened in between? It was OpenAI GPT-3 back in spring 2020 that made this difference. When we looked a month ago, in March 2023, you can see that the community prediction is here the year 2028. So it's already in this decade. And it means that just a month ago, GPT-4, by the way, brought it 3 more years closer. It means now when you look at Metaculus, it tells you that the first instance of publicly open AGI, publicly known AGI, is going to be in the horizon of 3 years, while 3 years ago it was in the horizon of 30 to 40 years. So maybe the exact dates are not like for granted, but the point is we burned 90% of the timeline that we have. We burned 90% of the buffer that we have. Why this has happened? Why this has happened last year? Only within 1 year, more than 15 years. It was basically no time to discuss this in more detail, but I can tell you it happened before, like half a year before ChatGPT. You can check the prediction that you can check the Metaculus that ChatGPT actually didn't change the prediction at all because it was already anticipated. It happened in the spring where with like huge Google models, Google large language models, Google Palm, and Google Chinchilla. That was the first thing, and how just sheer scaling enables to emerge like ever more complex models of the world. Then it was like visual conceptualization, so other foundation models, specifically DALL-E 2, Google Imagine, Stable Diffusion, and Midjourney, meaning you write a text, it creates a visual representation of the text. It means like not only we are able to, in an unsupervised way, which is very important, all those systems are trained in the unsupervised way. It means they can just read the whole internet and they don't need any human supervision. And by performing some pretty simple training task, they like all cognitive capacities kind of emerge on their own there. This was like a super important finding. So we now a year ago had this for text reality, textual reality, visual reality, and the third part that is completely omitted from like public space was the so-called Socratic models, which is the example of so-called multimodal models. They basically tell you if you plug in multiple single modal models, like one modality is text, the other modality is visuals, third modality could be motion, fourth modality is audio. If you just plug them together in a very interesting way, quite simple way, it just blows your mind. It's crazy. The performance then is super crazy. Now, where's the problem? This is like, what is ChatGPT? There's this meme around the internet. It's called Shogot. Shogot is the nice creature behind, that little face. It's like a mythical creature. Why it is there? Because by unsupervised training of large language models. And what this training does, it basically, the model, the huge neural network, transformer neural network, reads the text, reads N words, like quick brown, and tries to predict the next word, quick brown fox. So like pretty simple task, and voila, all those competencies appear. But imagine that a human would acquire language in this way. What would happen there? The representation of language reality in the mind of that being would be completely alien to us, like absolutely alien. It's so basically GPT-3 has like very, very good language representation of the world. It like saying that it's a statistical parrot is absolutely invalid statement, because the same way you could say humans are statistical parrots as well. Saying that it's stupid or that it doesn't, saying that it doesn't understand us is pretty valid. The point is it has very, very different and incompatible models of the world. But the models, the way how it models and the sheer scale of how it models the world is basically superhuman. And what you do when you design ChatGPT, you apply a little layer of so-called reinforcement learning with human feedback, where you basically slightly torture, kind of metaphorically, mathematically torture Shogot, so that it just moves its tentacles to generate sentences that people prefer. That's basically what reinforcement learning with human feedback does. And from my view, ChatGPT was not extension of GPT-3. ChatGPT basically was a reduction of GPT-3. Like GPT-3 was like very interesting, creative, and very, very alien Shogot. And we reduced it to generate some things that are like more compatible with how humans use language for the human perspective. The problem here is that anything you tell to Shogot, you have no idea how to see how it really represents the reality. You have absolutely no idea. So what do we know almost for sure? In the medium or long term, AI will outperform humans in any cognitive task. For the narrow AI, it's like for granted, and for general for AGI, it's like very likely. So we could say like everything is under control, right? Because now we have this super cool non-biological system that will one day outperform humans. And again, intelligence is not to be like humans, or it's not to pretend to be human. Intelligence is a form of competence. So it will outcompete humans, basically. It doesn't mean it will be like humans. It will outcompete humans. So everything is under control, right? Nothing can happen. Well, sadly, this is exactly not the case, because the newly emerging scientific field of so-called AGI alignment has been around here for like maybe, I don't know, 5 years. And during that time, it didn't give any progress. Alignment means we want to align the values of the AGI system, future AGI system, so that it is compatible with the values of humankind. Because if it is not aligned, then it might be one of the last things that humanity actually creates. Because imagine it creates a psychopath that will never die, that is absolutely capable of coordinating itself across the globe in the speed that no human can compete with. And we will basically not have the keys to steer it. We will not have the brakes, we will not have the steering wheel. So this must not happen. Now, why is AGI alignment so hard? Why is it such a damn hard process? Like, this is a joke that I took from Scott Alexander's blog, Astral Codex 10. Well, whenever you have to explain a joke, it's not a joke anymore. But I'll try to do it very quickly. Like, I have like my favorite example of a strawberry picking robot. Imagine you create a strawberry picking robot through a reinforcement learning process. So you give it a mathematical reward anytime it picks a strawberry and throws it in a bucket. Like pretty simple, right? It's got camera and you train it. Then you ship it to your customers, and they suddenly start to like call you and say, like, look, this robot, it went crazy. It just picks strawberries and throws them at the street lamps. So you go there and you ask, why does it through strawberries to the street lamps? And then you realize that they operate it at night. And so the brightest point on the robot's camera is the street lamp. So your original idea that the robot represents its goal through the strawberry into the bucket, it represented it in its own alien way. You have no way how to internally, for yourself as a human, represent what the true goal of that entity is. You just don't know. You suppose that in that distribution of your training data, it did what you wanted it to do. But now what you're facing is so-called OOD, out of distribution problem. Well, what's the solution? You can just say, okay, let's train it like Tesla does, let's train it under every environment conditions. But you can feel that like it's not that simple, because, you retrain it, then it works okay night, and then a Drunko comes with a big red nose, and the robot just jumps in and just pulls the nose of the Drunko and throws it into the bucket, and you say, okay, if we had more people with red noses, it would have been like much better. And so this is OOD. We can like kind of try to fix that problem. But the worst problem is that the AI alignment tells us that mostly it's very likely that every agent, complex enough in the world, will be a kind of deceptive agent, which means that it will kind of it will be optimized, it will be incentivized not to tell the truth about its true goals. So in this sense, imagine that this robot was driven by GPT-4, maybe GPT-5, with a very complex model, telling the robot, okay, look, there's going to be an engineer who's going to test you if you show the proper behavior, and if not, the engineer will just change you. And what if that system, that robot, somehow created the world model that says, my true goal is to throw strawberries on the street lamps. And I don't want any stupid engineer to change that. So your optimal behavior would be to pretend that you threw it, and you know what the engineer thinks about your true goal. But you know that he is mistaken. So you basically pretend that your true goal is to throw strawberries into a bucket, whereas, and you'll be waiting for your time to throw strawberries on the street lamps. And this is the aspect of having a very complex, non-myopic model of the world, such as GPT-4 or maybe future GPT-5 models. So now what existential risks are, now a little detour. Existential risks are even worse than global catastrophic risks. Global catastrophic risks are things like drastic loss of biodiversity, destruction of ozone layer, aging, but it basically means that the society can survive, global society. And you can see here in the orange of that graph, of that matrix, that existential risks are everything else, like even worse things that are like terminal and transgenerational, and even worse, like hellish and cosmic. And they're like, probably the most influential book on the research of existential risks. By the way, existential risks are not researched that much, given how important topic it is. It's the book is the book The Precipice by Toby Ord, published like 2 or 3 years ago. Last year was published even in Czech. So I really recommend you reading this book. Toby Ord basically says, and it's like not that he says it from top of his head, he says it under 10 years of intensive research, that the gravest existential risks that we are facing now are anthropogenic risks, meaning the risks caused by humans, not the risks like the comet will strike us or super volcano will explode. And now have a look at this table. This is like, I cannot argue about every single, but these are the top existential threats for the rest of this century. And have a look at misaligned AI. It gives us a probability, according to the Fermi estimates in the Precipice book, 10%, that it will basically be the cause of existential catastrophe by the end of this century. So the overall, existential risk is 1 to 6. So it's a Russian roulette, basically, that we're playing with the world. That by the end of this century, the human civilization will end. Read the book, either The Precipice or a more recent book by William MacAskill, What We Owe the Future. You will learn how these numbers are being created. And you can see from this table that misaligned AI and bioengineered pandemics are the far gravest things. So now, where we are facing, we're creating, and this is like the kind of last slide I like to show here, because it's very timely. You've all noticed an open letter by Future of Life Institute calling on all major AI labs to pause development of more capable models than GPT-4. So first thing, it doesn't say pause AI development. It's like stupid media image of that. It says pause creating GPT-5 and refocus intensive AI development efforts on where it is needed, meaning develop a tool, the tool that is capable of identifying how Shogot models the world, how Shogot models the inference processes, how Shogot, and if Shogot models the world differently than you think, then just have a tool to go down into its internal representation and change those concepts, change those things like very, very directly. And as long as we don't have this tool, meaning like brakes and steering wheel for Shogot, or maybe now Shogot it looks like, I don't know, like some dog or something, like pit bull terrier. So if you don't have steering wheel and brakes on pit bull terrier, then please don't ever try to build a Tyrannosaurus Rex. It's like building a car without brakes, just saying, okay, there's gonna be any uphill and it's gonna fix itself. So for my part, I definitely support this open letter. I think it's one of the most important things now in the AI concept. I myself signed it. And I at least suggest you look at this AI safety landscape from this perspective. So that's all for me for now, due to time constraints.
Okay, thank you for this informative, optimistic presentation. As we
well,
said
the optimistic part is that it's actually we have it in our hands. It's the most optimistic part. It's not like a comet coming here or super volcano.
But I take this opportunity to ask the first question. Since the AGI seem to be like better in everything, isn't that a good idea to actually give the task of align AGI to AGI?
Well, but you will never know what the real goal of that system is gonna be. So this is, I think it's like saying, okay, I'll pick up a random super smart guy. He might be a psychopath. I'll ask him, are you a psychopath? And he says no. And so I ask him, are you gonna be like true to me? Yes, I will. Will you not ever cause me any harm? No, sure, I will not. Wink, wink. Okay, so let's go. You know, this is the keys from the world, and let's go fix it.
And by the way, there will be multiple AGI, right? What about the competition between them?
Well, that's a very important question. Now, everybody's asking me, okay, what if we pause like the Tyrannosaurus development, like GPT-5 development, and what about China? Well, like imagine this: it's like a nice geopolitical, game theoretical issue. It's like it's similar to so-called chicken race. Chicken race is you've got two cars racing to like against each other, and whoever like just goes to the side is a chicken, is a coward. So one of the ways how to win this game is to demonstratively throw away the steering wheel, but you must not forget to tell the other guy, because otherwise it would be like in Dr. Strangelove, who was like famously saying it's quite not a good idea to create a doomsday device and to not tell your enemy about the doomsday device. It's a very bad idea. So basically, chicken race, in a game theoretical concept, you threw away the steering wheel, thus showing that you have no capacity of really, be the chicken. The interesting question is, what if the other guy just throws away the steering wheel? Then, but our situation here is, how is China or any other geopolitical adversary incentivized to create a misaligned AGI that could turn against themselves? Let's say there's going to be a war, and China would say, okay, we want this super intelligent AGI to create everybody but Chinese people. But that actually means they already aligned AGI. They have tools. They know how to do that. So far, nobody knows how to do that. So even China would not want to race to a super competent, misaligned model as long as the West doesn't race there too. So the only reason China is 1 year behind us, they are racing there, is because we're racing there too. It's a chicken race. So one of the geopolitically feasible solutions, in my humble opinion right now, is for the West, meaning for us, to demonstrably, throw away not the steering wheel, but the gas pedal. Just showing demonstratively, knotting our legs behind our head, that we are not racing there, and we can prove it to the adversary. And so adversary, meaning Chinese now, would be now incentivized to slow down as well, because they don't want to create misaligned AGI. They would prefer to have aligned AGI, and if they demonstratively see that we are pausing, going to the alignment way, they would most likely pause as well. But this is only a short opportunity window, maybe 1 year, maybe 2 years. And it will not work the same way when they already achieve the Tyrannosaurus Rex, misaligned Tyrannosaurus Rex. Because at that moment, if we slow down, they will not be incentivized to slow down as well. They will be more incentivized to just play the very risky way. And this is exactly what we don't know, because we're creating non-biologically aligned entity more capable in achieving any goal. And we don't have the steering wheel for that.
But still, you mentioned a lot of concerns, and that there are some activities already happening, like the petition to slow down the AI progress and so on. But the people are already scared. So what do you think will help us to control the AI?
Well, not to pretend this is not the issue. Because as I see it from the majority of AI community, they're just in the kind of very motivated reasoning, explaining this is not the issue. Like I would say more than 50% within AI community is against that open letter, saying either AI will never be competent enough to be dangerous. So I'm asking, why the hell are you working on that? If that is such a stupid thing, why are you wasting your time on something such incompetent? This is like pretty obvious case of motivated reasoning. Another case would be, okay, so it's gonna be more competent than humans, but we will figure out one day how to fix it. This is like super irresponsible. And the third case would be, it's gonna be smarter, meaning more competent, and for some reason it will maybe somehow on itself start to like us. And look, and what I see recently was a tweet by Jan LeCun from Facebook. It was shocking for me, because he's like a strong opponent, vocal opponent against the open letter. He was saying, okay, now even in human groups, like less intelligent people are in charge of more intelligent teams. So it's pretty okay that less intelligent humans will be in charge of more competent machines. But this is like so big fallacy. Because, why are we able to do that? Why you can have a stupid manager and still work with it? Because we're humans. That being is like a same instance of our kind. And we were primed by evolution. We run on the hardware that is equipped by emotions, altruism, kind of attachment to other person, and we just cannot go and kill unless we're psychopaths. But the alien Shoggoth will never be aligned in such a way. So maybe just an example, have a look at other Homo species. Where are they? Where is Homo erectus? They have been here for 2.5 million years before Homo sapiens came. Then Homo sapiens came, we've been here just 200,000 years. And Homo erectus suddenly disappeared. Every other instance of Homo species is gone. Where did they go? Most likely, we don't know for sure, but most likely they were just, extinguished by Homo sapiens, because Homo sapiens was far more capable.
Okay, I'm slightly worried at the time limitation. I will be asking. I have several questions over there, but you can check the website and look for the question and probably answer them.
If those questions are kind of world-saving related, then just I suggest people check my webpage. There's an email, and they just can forward them to me. And okay, if it is like a joint activity for saving the world, I'd be more than happy to answer.
Okay, thank you for scaring us. That was
you're welcome. Always pleasure.
So thank you both speakers of the first morning block, and I remind you that there will be a break in the moment, and I remind you to answer a short question on this reference or use the QR code. And when you answer the question after the next block, we will drawing a winner of this, I guess, headphones or something. So see you in like 10 minutes.
See you.
Unicorn University, tenkrát to vlastně byla Unicorn College ještě, jsem se rozhodnul studovat, protože jsem znal Unicorn a dozvěděl jsem se, že bude otvírat svou vysokou školu, že tam bude kladený důraz na spojení praxe a studia. Tak kdo by to řekl, shodou okolností jsem se při škole dostal na part-time do Unicornu, konkrétně do Unicorn Systems, kde jsem dělal práci marketingového editora, takže jsem měl na starosti přípravu novinek na web, přípravu newsletterů. Provázanost Unicornu jako firmy, jako školy hodnotím pozitivně. Je to vlastně, nebo byl to vlastně jeden z těch hlavních důvodů, proč jsem si tu školu vybral. Ať už se to týká studia samotného, kde nás vlastně učili jak klasický vyučující, tak lidi z praxe, přímo z Unicornu nebo z jiných firm. A potom samozřejmě i ta možnost práce jak při škole, tak práce potom dál po škole, kdy jsem v Unicornu pokračoval. Aktuálně pracuji na pozici Operations Manager v rámci Unicorn vysoké školy, pod kterou vlastně spadá jak Unicorn University, tak Unicorn Publishing, tak Top Gun Academy, vlastně naše interní vzdělávání, a mám tam na starosti zdroje, takže majetek, lidi a především finance. Moje kariérní cesta zpátky na Unicorn University byla trochu klikatá. Po dostudování bakaláře na Unicorn University jsem pokračoval v magisterském studiu. Při škole jsem dál pracoval na part-time v Unicorn Systems a následně po dokončení magisterského studia jsem nastoupil už na plný pracovní úvazek a měl jsem na starosti řízení projektů návrhu grafického uživatelského rozhraní. Po pár letech jsem ještě se vydal na zkušenou mimo Unicorn do oboru gastra a hotelnictví. V rámci rodiny provozujeme v Orlických horách hotel s restaurací a ten jsem asi 6 let vedl a řídil, až letos přišla nabídka zpátky z Unicornu. Já si myslím, že na Unicorn University by měli jít lidi studovat proto, že ta škola pořád nabízí to, co nabízela už od samého začátku. To je to propojení praxe a studia. A především taky ta škola umožňuje velmi flexibilní způsoby studia, což třeba za mě nebylo, ale dneska je možný studovat při práci, ať už v nějaké kombinované formě, tak v plně online formě studia, kdy vlastně člověk nemusí už v dnešní době u některých programů vlastně od zápisu až po promoci do té školy vůbec nikdy přijít. Zvládne všechno vystudovat online, můžou toho pracovat, můžou toho cestovat, může studovat v angličtině. Takže to jsou věci, které na našem trhu nenabízí žádná jiná škola. Přijďte studovat k nám a uvidíte, že si to nevymýšlím.
To mrtvý.
Ale to tam nedáte.
Hello, my name is Tomáš Petráš. I work as a project manager at Unicorn. I manage the development of our DAMAS platform used by the electricity transmission system operator in Slovakia. And thanks to one of the projects on this platform, it will be possible to transmit more electricity within Europe at an overall lower cost. I joined Unicorn 11 years ago while still a student. Back then I started as a tester and participated in the bank branch platform development project and also helped with the development of internet banking. In the course of the cooperation, I also tried the position of an analyst, but a huge career challenge came when I started the position of a project manager. In a relatively short time, I learned a lot about the project management and also expanded my knowledge in the field of energetics. I'm glad that Unicorn gave me such an opportunity, and I'm looking forward to the next challenges that are waiting for me.
Dobrý večer, dámy a pánové. Dobrý večer. Já se jmenuji Jaromír a dovolte mi vás přivítat na dnešním koncertu. So
My journey with Unicorn University started very spontaneously because I had no idea what to do with my life, and I decided. I went on the internet, was surfing through the internet, and I saw advertisement of Unicorn University. I checked the website, and all the information about applications was very clear, and also study department helped me a lot. So I wasn't waiting for too long. I applied, and I never regret this decision. Here at Unicorn University, the most interesting experience it was projects. Because even when we came to university, we basically knew no one, but the project and some common goal, it put us all together, and we could be friends already. We also could help each other anytime when we don't know the answer. We know we can ask our colleague, and that was the best experience. In this project, we go from the very beginning. It's starting from documentation, business requirements, business model, application model, and you go through the same structure as you will experience in a real-life project. And thanks to that, once we are graduating Unicorn University, we are ready for the real-life experience. My two very favorite teachers, if I can say that way, it's Adela Vanštejnova and Marek Biranek. Adela Vanštejnova, she was with us since the first project. And even when you feel like you cannot understand some stuff, she would explain it in such a way that I think anyone can understand, and it's very important. And also she would find time, even if she is very busy, she will find some time to help us to explain us stuff. Marek Biranek suggested me to work for CERN. Everyone knows about CERN, and I believe anyone would dream to work there. Well, I was definitely one of those people. And Unicorn University, they developed a productional database for internal detector in Atlas. I was working as a front-end developer there, developing components for this productional database. It was amazing experience, and it helped me definitely to understand better how all development process work, and definitely I gained some experience. I want to thank Unicorn University for changing my life, because just 3 years ago I had no idea what to do with it. I had no idea what I want to study. In 3 years from being a waitress in the bar, I became a software developer. And thank you so much for creating the love for what I do. It was like, study at Unicorn University, what everyone's doing, no?
Nacházíme se na veletrhu čisté mobility Eslon 2021 a vy si teď pojďte podívat, co všechno umí ChargeUp nabídnout.
ChargeUp je komplexní řešení pro elektromobilitu, které není jenom dodávka nabíjecích stanic na klíč, ale i softwarové vybavení, které vám poskytne maximální kontrolu nad vaší nabíjecí infrastrukturou a koncovým klientům plný komfort při využívání služeb veřejného nabíjení.
Naše portfolio obsahuje AC i DC dobíjecí stanice. Dodání zajistíme od úvodní studie proveditelnosti přes projektovou dokumentaci až po výchozí revizní zprávu. Samozřejmostí její kompletní stavební realizace.
Více informací najdete na www.chargeup.net. Budeme rádi, když se nám ozvete.
Na Unicorn University jsem se rozhodl studovat, jelikož mi to doporučil známý a říkal, že je to nejlepší škola, pokud se chci učit programovat webové aplikace. Studoval jsem 4 roky na Karlově univerzitě obor biochemie, Ale potom jsem se rozhodl, že už to nechci dělat, tak jsem se ze dne na den rozhodl, že nechám biochemii a půjdu někam jinam. Na přijímačkách byli všichni vstřícní a milí a proto vše proběhlo bez problémů a přijali mě na školu. A tak jsem tady. Nejvíce na mě zapůsobil pan ředitel Beránek, jelikož jsme ho měli jako vyučujícího v prvním ročníku letním semestru na předmět architektura cloudových aplikací, kde jsme pracovali v týmech. Měli jsme 4členný tým, ale 2 lidi z týmu nakonec těsně před zkouškou odešli. Tudíž nám pan Beránek prodloužil zkoušku na měsíc. A dokonce se mnou právě že konzultoval jednou týdně, jak to mám tu aplikaci psát, kde dělám chyby, prostě co bych měl upravit a tak. Už jsem měl pocit, že z té školy vyletím a že to není pro mě, že programování je pro mě něco úplně vzdáleného, ale nakonec s panem Beránkem jsme tu aplikaci dotáhli do konce a zkoušku jsem dal a postoupil jsem do dalšího ročníku bez problémů. V druhém ročníku díky studijním výsledkům jsem dostal možnost práce v Unicornu a využil jsem nabídky práce pro projekt na pojišťovně VZP, kde mi dost pomohla projektově orientovaná výuka a pomohla mi hlavně v tom, že jsem se bez problémů začlenil do pracovního týmu. Věděl jsem, jak v týmu pracovat, věděl jsem, jak pracovat prostě s Gitem, s nějakýma základníma programama. Bylo by složitý získat tyto zkušenosti v práci. Nyní jsem na projektu japonské investiční firmy Toranotech, kde vyvíjíme druhou verzi aplikace pro investice. Studium na Unicorn University bych rozhodně doporučil. Přestože jsem se věnoval jinému oboru a neměl jsem žádné zkušenosti s programováním, tak na Unicorn University jsem se naučil programovat a získal jsem práci v oboru úplně bez problémů již po druhém ročníku. Takže nyní mě živí to, co mě baví, tudíž IT.
Flexigy, the key to the world of flexibility aggregation. European energy transformation is constantly accelerating. In the pursuit of energy independence and climate neutrality, the amount of electricity produced from fossil fuels is being reduced. Transportation is heading towards electrified fossil-free future too. In the electricity generation, the number of classic controllable coal and nuclear power plants is declining across the entire European grid, while the share of intermittent solar and wind resources is increasing fast. Moreover, the electrification of transportation and heating may cause even more stress in the system. To maintain the security of electricity supply, the role of electricity storage and flexibility becomes crucial. In connection with the decentralization of generation, the conditions in the grid are getting more and more volatile. The way production and consumption are controlled is changing. Everything is happening faster, in shorter time intervals, or even
Hello, ladies and gentlemen, welcome back. We will be again talking about AI, and now from the perspective of automotive. And we have got Jiří David from Škoda Auto University, and he will be speaking about using AI in automotive industry. I think it will be very, very important. Yeah, it is a very exciting field because we collect so many data in the car, and the data can be used everywhere. And then the discussion is how we actually use the data, of course. Hello, good morning. Well, I will be focusing on the possibilities of use of AI, how we can use it in automotive. Well, the automotive industry is an industry where we can use AI for the manufacturing stage, but also in the car, in it, when we use it. I will be focusing on the car, on the vehicle itself, and we'll be speaking about the trend. The current trend, as we might know, is that every new vehicle has got some automation, some degree in automation, and we see the trend of autonomous driving. We can actually speak about the two trends, which is the first trend is the automated highway, and that means the car will go somewhere and the driver will only put in the system the destination, and the whole system will actually start working as an automated system. And another actually possibility is to use the assistance systems that has to do with the drivetrain, with the safety issues, and here the systems, the assistance systems, actually support safety behavior of the driver. They should be supporting his decision making. The first system, called automated highway, is a concept. We have got not technical issues, but legislative issues. That means that we speak about liability, criminal liability. Who should be liable if there is an accident? In the other field, assistance systems, the liability is borne by the driver. That means assistance systems may be implemented instantly, and we get new development with each generation. Those two concepts can be well interconnected technically, and of course they are developed and they actually influence each other. Let me actually speak about the adaptive cruise control, ACC. This is a system which has got various alternatives. We have the so-called conventional cruise control, which works on the road as a simple speed controller and keeps the car at a constant speed. Adaptive cruise control is more advanced. There are actually sensors and radars and cameras used and actually mounted around the car, on the car, which actually gives us information about the moving of the vehicle, about the situation around the vehicle, and we are able to react, or the systems are able to react if there is an obstacle.
And if we are in a column, the cruise control will help us to get closer to the vehicle ahead and still preserves the preset speed of the car in front of us, or if there is a fixed obstacle, it's able to stop the vehicle altogether. Another type of cruise control is so-called predictive cruise control, PCC, which is probably the latest model, the most developed one. There are several modifications as compared to adaptive CC. It can work with information around the vehicle, and it's able to work as well with the surrounding as well. I mean, from traffic signs, it can read them and deduce different parameters. Let me focus on this system, and showing two examples, I will try to explain how neural networks can be used for recognition of traffic signs, and how subsequently it can be used for processing parameters related to driving to route. The basis lays in the task. The task I'm going to present you is rather complex. I chose just a part that consists of recognizing numbers in traffic signs, limiting our speed. As you can see, the text used for recognition can exist in different formats, in different colors, and so the task needs ability to cooperate with recognition of image. First, there must be ability to recognize a traffic sign, whether it does correspond to the needed format. If the answer is yes, we are able to decode the whole chain of other information. If we concentrate on traffic signs limiting speed, due to digital processing of the picture, of the image, we are able to select a chain of figures we want to recognize, and subsequently we select individual symbols that are then recognized. And let me focus on in what way we are able to start with a graphical format and pass to practical information. In order to do that, I will show you usage of neural networks. Each of the image is here in a certain pixel number, particular level of recognition represents neurons in the final neural network. Of course, this is not a completely comfortable way, because we can use with just a certain level of resolution. We do not take on board all neurons. We select just those that fall under so-called mask, and the cross points, the points, the individual points of the mask represent individual neurons for us. These neurons can be further processed on the neuron networks, following different types of neural networks, whether they are recurrent. As a representative, we have here Hopfield neural network, or we can use networks that look more forward, here represented by multi-layer perceptron neural network with a back propagation algorithm. They differ in ways of learning, and therefore, in terms of recurrent network, learning time is rather short. However, fitting itself represents an interaction process that can be rather lengthy. On the contrary, multi-layer perceptron neural network the learning is rather longer, but fitting is shorter. And therefore, if we need a quick reaction, we usually opt for those multi-perceptron networks due to good speed of fitting we need. This is an example of training set. It shows that we have to train the neuron network for different sources. The example shows that we do not train only on complete patterns, but we introduce into our training set also some de factus articles or items so that we get as close to reality as possible, and therefore you can see some signs have a lower readability or are incomplete, and this is the way how we teach the neuron network to recognize even incomplete or de factus patterns. With a proper software, we can get the different variants of individual topologies, and depending the software used by us, we have different possibilities to teach, to program topology. We can program it by itself, and depending the algorithm of learning we choose, the result is also different. This was our first application. The second application will be oriented on completing the application. We will have a look at how we can use today different systems for predictive cruise control. And we are also discussing the fact that this predictive cruise control can use data obtained from GPS. It can also monitor the condition of the road surface, the condition of our vehicle, and therefore can predict cruise conditions for the following distance, dictating the format of driving, style of driving, so it is eventually safe and pleasant for the crew of the vehicle. So we will have a look at these systems. They are shown on a simplified model. As a starting point, we use mathematical and physical model of the vehicle movement. Some basic equations are set describing all the forces involved and all the parameters influencing the style of driving under given conditions, and we try to complete it with further parameters that we can obtain during the driving. The main parameter we are interested in is adhesion. In other words, how well we are able, how safely we are able to respect adhesion parameter of our tires to the road surface, which has a clear effect on our safe speed and safe braking. Adhesion or grip value is connected with many different things, such as condition of tires, condition of the road surface, speed of the vehicle. We can use basic physical equations for description of the situation. However, when we drive, we do not have a chance to get such data, and so we have proposed a model of censoring the road. The model uses a capability of digital image processing, and is able to determine what's the surface of the road, and in addition, based on data of the surface of the road and the vehicle itself, it can get the necessary preconditions for solving the situation. It's a more complex task, and therefore there are more neuron networks involved in solving such a task as compared to the previous example, previous case, where just one neuron network was enough. We propose 3 neuron networks here. The first one predicts interval value of coefficient of adhesion based on 3 categoric variables that characterize type of road surface. With camera, we are able to recognize different types, such as concrete, asphalt, gravel, etc. We can also define the surface in terms of its condition, whether it's a new surface or whether it's been repaired in the past, or whether there is ice layer on it. And the third parameter is what's the surface of the road depending on the weather, whether the surface is dry or wet. These are basic variables we get through analysis of the image. The variables I listed, we get the upper and lower limit of the coefficient, which is further used for further calculation. The second neuron network is also predictive one. We deal with prediction of slowing down interval. In other words, we want to find out when we have to start slowing down in order to ensure safety of driving. In here we have, as I said, the second neuron work, which works with the outputs of the first neuron networks, and in addition we have parameters characterizing braking and the slope of the road. We can get either from a given map system or from the GPS system, using all the information it produces. The third neuron network we use for this task gives us the final result, which is prediction of a maximum value of slowing down in the 3 forms: minimum, maximum, and median. And it says to the system when it is to slow down based on either an obstacle present on the road or some other type of limitation. And we have to take into account also type of vehicle, whether it's a small, medium, or bigger car, also condition of brakes, and also a load of the vehicle. All these data are parameters we can obtain quite easily without problems due to different sensors that are involved in solving the task. The resulting value generated by the mentioned neuron networks is then passed to steering unit, and this steering unit reacts practically to the situation analyzed. Of course, what can happen is a situation when unpredictably, suddenly, there is an obstacle, such as, for instance, deer crossing or some other animal crossing the road. If so, the information is passed over to other assistance system that will do all needed for a fast breaking down and prevention of collision with the obstacle. As for the two tasks mentioned, I would say that the first task will be used for classification when we use neural networks for digitalization of the situation, and then we digitalize it, and the output are the data, and the data are used as inputs, and we can process them. I forgot to mention that once we have actually read the numerical symbols, we just put them into a digital piece of information which is processed later on. The second task showed us the possibilities of prediction. In many cases, the neural networks are used by us for predictions of values which we need, which we cannot actually derive from mathematical background, and it is rather the neural networks that actually cover for the mathematical background. The advantage is that we can actually process any values of any nature, and those values, if processed or used conventionally, we would not be able to actually put them together, but we can do that if they are part of the neural network. Let me sum it up by saying that as technology develops, we attempt to actually replace the human being, the worker, in the processes by a more developed system. And we try to describe the methodology. And those AI models can actually solve various tasks. And what I would like to say is that AI methods have not reached their limits yet. There will be more development in this regard. And that's why we may expect their further proliferation in various fields, such as automotive or in households as well. And the vehicle, as presented by me at the beginning, we have the objective there, and that is autonomous driving. And whether we actually reach that objective soon or later, that will depend on AI largely. Thank you. Oh, thank you for this very nice lecture, which actually showed us the technology background and also engineering and automotive. We see what people or workers always address in those technical fields. Now I'd like to ask you, how often do you read that sign, that tag? And if it says that it has to be damp or wet, then it is written in a local language, right? Well, of course. As for the text, let me explain it. This sign will be segmented into subsegments, and then we look for chains, and they will be analyzed separately, the chains.
That means we know what signs we have, and that's why we are also able to do the following. If there is one sign with some text, then we know in advance what text there will be, and that is why we can teach the neural network using that text expected there. Well, as for actually reading it by reader or a camera or a sensor, we have to have a high enough resolution. We have to have tests at various speeds, and the sign will be read several times repeatedly, and then it takes some time so that we can actually create a complete image. Another question on my part, does it happen that those limits which are actually in the rear of truck will also be read as a sign? Not really. The cameras know where the sign is placed, and moreover, we can also focus on the space which we need to be described or read. Okay, let me ask something relating to it. How often do you think about upgrading the models? Well, what models do you mean? Neural networks, and I assume that you will have a respective model in the car so that it works. So how often do you upgrade those models in the cars? Well, I have to admit that we have not been addressing this issue yet, but in my humble opinion, I think that today we can actually update software autonomously. Even in the cell phones, it happens autonomously, so it is not an issue. If there is a change in the software, then we can actually update it, upgrade it. And if the car or the driver comes to checkups regularly to the service, to the car dealer, then they can actually upgrade it. Okay, and I would say that in the last century there were the first attempts at reconnecting the cars, interconnecting the cars. And the question is whether that is also possible, that cars actually exchange information. Yes, of course, this is how automated highway works. I mentioned that there will be vehicles or machines that will communicate between each other. Of course, the cars will actually exchange information with each other. Okay. I would like to ask about this situation when cars are interconnected, and how about the driver? If the driver is in the car, will the car actually recognize the driving style of the driver? Some driver likes speed. Yeah, there are various studies conducted. There was an international research team, and they used a driver, and the network actually learned the habits of the driver. That would be one alternative, possible alternative. Or I imagine, how should I put it? safe driving, I would say. A safe driving model for the average driver. Well, I imagine that we will have chatbots driving for us. However, I would like to thank you for this very inspiring presentation, and now we will switch.
Describe a deep learning and a high data availability and the necessity of having a mathematical background for it. Because of course we are aiming to a situation where we wanted to use AI as a service that we can join the website and use it. However, still it is wise to know the background of the problem, right?
Yes, and I'm really excited about this topic and about this presentation, because we know that deep learning is a pretty wide and complex field. And I noticed that there is something about how to make it easy. So I'm really looking forward to it. And now,
so let me invite Josef Nový from Czech Technical University and CERN to present what is easy, what is hard.
Thank you for the introduction. So in my presentation, I would like to take you from beginning of the artificial intelligence to the current landscape of deep learning. Basically, the beginning of the artificial intelligence can be set as 1943, where the publication about perceptron appeared by McCulloch and Phil. The development of the artificial intelligence actually stopped, or interest in the development stopped twice during this time. First, it was between 1969 and 1974, and second time it was between 1998 and 2006. Those periods are called neural winter, and they were caused by several problems. One of them was computational power. Another datasets which were not easily accessible or not present at all, and also problematic training of the networks, because the theoretical background was not there. Those problems correspond nicely actually to the creation workflow of the artificial intelligence or neural networks, which are get data. So you have to first have the data on which you want to train your network, then preprocess data. Your data have to be prepared for the model to accept, and this is true not only for the supervised learning, where you have to label them, but also for unsupervised. And then, of course, the creation, training, and verification of the model itself. All those steps needed some development in three different fields. First is network architecture and training algorithms, which we can basically put into the field of theoretics in the artificial intelligence. Then hardware, which allow us to process and train larger models and larger datasets, and tool sets, which allow more people to get involved in the artificial intelligence, as they make it easier for people to access those resources. We also have some current challenges which were already mentioned in previous block, actually. And it's not only misuse of deep learning, but also fast development of the large models without appropriate alignment. So now for the beginning of the neural networks. It all started by basically inspiration from nature, from neuron. Simple perceptron was created, as I said, in 1943. This usable for, still usable actually for many applications. And good for this is that it's possible to train it also manually. You can use Boolean algebra and prepare your neuron without any need for processing of the data. It's small and easily understandable. I can show you simple code in both C++ and Python. I will also show codes for more bigger models. Usually you will see that C++ is a little bit longer than Python. Here is also really important mathematical equation for the perceptron, which is used for calculation of the response. So just keep in mind how long the code is and how complex is the first network. It's not that big. But if we go further, we are getting to multi-layer perceptron, which is actually still key part of many architectures as last layers in the models. It is very nicely usable mainly for classification, but also game AI, anomaly detection, medical diagnosis, image and speech recognition, many fields where you can use this layout. But the problem is both with training and complexity of the problem, because it involves several layers of fully connected neurons. So each neuron in one layer is connected to each neuron in next layer, which means that if you want to analyze, picture, full picture or video, you need a lot of variables that you have to train, and this can be a problem. I just hint a thing that you can try. You can try at playground TensorFlow.org to design some multi-layer perceptron to test how it behaves. You can change how many neurons you have in each layer, what inputs you have, and also which functions are used in the neurons. And then you can see how it teaches classification problem. Okay, so here we have code for multi-layer perceptron. You saw that it grew a lot from the single perceptron, but the code is not that bigger, thanks to usage of tools and libraries to help us implement the bigger model. Here we have, for example, again and NumPy in Python, respectively. So we have much bigger network, but not that bigger code. And now, when we want to go to even bigger and more complex networks, we actually almost need to use some bigger frameworks and toolsets, like TensorFlow or Keras, Coffee, or I know MXNet. It depends in which language you are developing, and they are not on the same level of abstraction. For example, TensorFlow is lower level, Keras is higher level. But still, it helps us implement bigger networks, mainly because you have prepared training algorithms for the networks. So, and what kind of networks we actually can use in such frameworks? In the past years, many different architectures emerged for different tasks that the human need to solve. you probably will know, or at least heard something about convolution networks, which are typically used for image and video processing, and are very nicely usable thanks to specific way that they are processing data. They are not fully connected, so you can have less parameters than in the multi-layer perceptron, and they are extracting features from the image, based on which you decide the class or classification of the image. Here is an example of some CNN network. You can again see that it growed a little, the code, but still it's not nearly as complex as it could be if you wrote it in just simple way as was in the multi-layer perceptron example. Another examples of those architectures are, for example, recurrent neural networks, which are used for signal, speech and time series, or autoencoders, which are highly used for cleaning noise from the images. But as I said, many architectures appeared. Here are several other examples, like generative adversarial networks, which use two networks, one that generates images, one that decides if they are true or not. And this way, the first can be trained to generate, for example, picture based on some prompt, or actually they can be also used for detection of anomalies in, for example, network transfer. So you can, in advance, stop some threads or exchange faulty equipment ahead of the actual failure. And of course, I have to mention in between new architectures also transformer networks, which are a big thing now with ChatGPT. Another thing that helps make the deep learning easy is availability of free datasets. This is actually huge advantage because before, I think maybe half of the time that you spent on preparation of your use case was preparation of well-prepared dataset, labeled data, because you need a lot of things, a lot of pictures. For example, if we stay in the picture classification field. And thanks to the free dataset, you can have some head start in this. Second part of it is availability of pre-trained models. Before I talked about the architectures that are available and implementation of these architectures are available in pre-trained models. This is also very useful for start because you don't need to teach the whole model, you just teach the last layers. Then you can use even the big model with a lot of variables for your application and don't need really some fast GPU-based server for teaching. You can teach it on smaller machine or in some virtual environment, and it helps a lot with smaller projects. And now we are getting to really interesting part, AI tools. With this, we are getting to the place that you actually don't need to interact directly with the model or the neural network. You don't need to teach it anything. You just give a prompt, which is actually also important knowledge to have. As you have to learn how to put a correct term in the Google search or anything else for searching, any other searching engine, it's also important to teach how to formulate your requests for the AI tools, like ChatGPT or image production, things like Midjourney, or I think now it's Adobe Firefly. It's the new also AI tools for pictures. Here I put some example of the image produced by the Midjourney and the prompt that was used for it. We can see that the pictures that it can produce are really nice, and you can produce many more styles. What is the most interesting for me as a software developer are Copilot and Code Whisperer AI tools, with which we actually getting to the point where AI helps to write another AIs and the code. It helps a lot and make the work of developer much more efficient, let's say. Okay, so that was all for development of the field, from perceptrons to landscape, deep learning landscape as we have now. And I would like to talk now about practical usage of deep learning, what we have at our university. Basically, the variety of use cases is really huge now, partly because development of the frameworks and also the free data sets. People can start with a nice project and get the good result really fast. But we should not forget about need for some background knowledge if you want to get the perfect results. Because for example, all the inputs in the networks are in some way transferred to vectors or matrices and tensors. If you want to teach your network, you always will encounter training methods. So it's useful to know what variables come inside and how these numerical methods are working. And of course, statistic and information theory is quite useful. As always, you have to define loss functions or some other way to describe your result that you want, or evaluate if the response of the system is good for you or not. Here we have some examples of smaller works, actually of the students. For example, the classification of architecture types, and also heat maps of the pictures, which show you what part of the picture is important, or architecture is important for the style. It used the convolution network for this, and also some transfer learning method. This is also a nice small project as a final exam of computer course about usage of AI for a simple football game. Actually, the student get to the point where it was almost impossible to win against the AI. So nice result. And one on which I am personally really proud is application of neural networks in augmented reality. Because normally when you calculate depth of the image, you use 2 cameras. But with usage of the neural networks, student was able to get deep depth information from 1 camera and 1 image. And on the pictures you can see comparison between 2 different models and the source image. Another nice application is utilization of convolution network for object recognition in the augmented reality. With use of Unity and TensorFlow, student was able to detect mouse or other objects and put the information about the objects from Wikipedia next to it. So it's proof of concept, let's say, for augmented reality. The neural networks or deep learning is also highly usable in, for example, healthcare. Here we see example of usage of segmentation for help with diagnostic creation on vertebrae and discs. Basically, model segment the spine, and it can then measure distances between vertebrae. It can nicely help doctors to make a more precise diagnosis or help to create a diagnosis. It's not the only place where you can use deep learning actually in medicine. It's also nicely usable for example, cleaning of the images of the noise, make the scanning process on MRI or CT faster because you can upscale the image or clean it. But we have to take in account that it's always better to use it as support and not direct diagnostic tool. It's better to use it as help and final thing. We also using the deep learning in CERN, in Ember experiment, where it's used for particle classification. Actually, CERN also developed its own toolset for machine learning, and it helps a lot making fast decision and reconstruct tracks, and detect anomalies in detectors, and many other stuff. So for conclusion, I would like to pinpoint that thanks to simultaneous development of both hardware, theory, and tools, the models grow a lot, but the complexity of code and usage of the networks is not that big. It didn't grow that much, so it's easy to get good results from AI. But I think it's impossible to get perfect results. Neural networks are always in some way about some statistics, probability that the response is true, and it's highly usable to have some mathematical background and theoric knowledge of the networks, how they are working, how they are trained, and so on. So if you want to use them in the full potential, you should learn some background things. And what's next in AI? That's probably a big question for many speakers today. So That's all for my side.
Thank you very much for your presentation. It was very nice. I mean, I have a really quick question that follows up, because I heard that this CERN project, they're looking for the particles. There was actually a competition. I don't know whether in this particle experiment that many teams were competing in sense of winning the best, I don't know, prediction or classification.
Not this one, but of course the particle identification is a big thing in all the physics experiments. So many teams are working on similar things. Yes. And in physics, you always try to have actually more teams that are not directly cooperating, because you want to evaluate your final product to have more, let's say, not related responses. So if two are true and one not, you can still decide which one is true. Even in the physics experiments itself, it's highly usable to have more experiments that are doing the same thing, and they can compare their results.
It could be complete. And maybe a quick follow-up. I mean, are you sometimes facing that there are too much data in sense of computational complexity or something like that?
It's always a race between the tools, hardware, and amount of data.
Or something that you are even not able to compete. That you were really facing some limitations of yours.
Yeah, of course. Now it's more matter of if you get money to buy the proper hardware, then that it's not available or not possible at all.
Okay, thank you for deep dive into the complexity of neural network. It looks like that you somehow skipped that easy part. But generally, as I saw the depth-based research, which is based on AI as well. This could be a huge game changer to many industries, including automotive. So do you continue on this research to take or to estimate somehow the depth from single photo?
The student is working on the stuff still, but we'll see. We actually have also a collaboration with another faculty, and we are also partially looking in working in automotive. So we have many projects and try to combine actually the outcomes of the smaller one to some bigger one and compare it with another ways how to get, for example, that information. It's always good to compare, for example, this neural network from single photo with traditional way of getting it from two cameras. And also, especially in automotive, you always try to get the information from more than one source to have certainty that the response is good and correct.
Yes, exactly.
I may be asking a different question again about the data, similar as before, but the opposite position. So what if the data, if you don't have so much data, data are uncertain, you know there are many exogenous variables you don't know about. Are you facing problems like that?
Yes, and typically they are solved by simulating the data. You prepare a mathematical model and use, for example, Monte Carlo to generate data what you want or need as basis. Then try on the real data. If they are not enough, you still have a way to teach your model, and then just evaluate or validate that the model is working good with.
Okay, so that's the one. What about this including the uncertainty in the neural network? Something like I'm heading towards this fuzzy networks and stuff like that.
Yeah,
maybe not
personally. I didn't try. So
yeah.
But for example, we now trying to prepare some process of producing also for the automotive automatically labeled stuff. So.
And
I think that's
Okay.
All from our side.
Maybe one question again. This about the speed, because sometimes we heard the speaker before. It's very important to have a quick answer, right?
Yeah.
So, is there applications where the requirements for the answer is to be really quick, and you need to tune it somehow.
Especially in physics, it's true. If you are at the physics experiment and you need to just choose what you take because you don't have enough computer resources to record everything. Usually from the experiments, you have to choose what you want to record. There you can use fast neural networks to decide what is interesting, what is important, and record just this.
And you create the next step based on the decision of the previous step. Oh, that's very nice.
Okay, I now notice that we have some
okay,
more
yeah,
time.
maybe.
So maybe one more question. Could you a little bit more give us the idea how about using AI in the medicine? Because we saw some photos from MRI.
Yeah. For example, in MRI, you can shorten the time the patient is inside, and you get more noisy picture. But with AI, you can clean out the noise and get the, let's say, similar quality as with long period of data taking with smaller one, which is especially usable if you need to scan something movable, like heart or something like that.
Yes.
Another field where you can use it is the segmentation. You can segment the bones and organs, and it is also quite usable. You can find some part of the picture which should not be there. It's also usable.
Yes.
Or automatically search for cancer or something like that in the pictures. So use cases are there, many of them, and it's more matter of not enough people than not enough topics, let's say.
Yes,
exactly. And of course, big thing is that it's a kind of safety application. So you have to take in account that you have to be really careful about the responses of the network.
Yes, it means that there must be someone who always validates the output and decides whether it is really right answer to the question or not. But on the other hand, we already mentioned the problems and the issues which should we somehow solve or mitigate when working, for example, with the data, because the photos or the results from the scanners are still somehow tightly related to the people, and we need to take care about this.
Yeah.
Okay.
So in the end, there will be doctors with many recommenders to just deciding which is true. Okay, we are not only out of people, but out of time. So thank you very much for a great presentation. It was a nice contribution. Thank you.
Thank you.
Thank you.
A pohneme se k další prezentaci.
And now we will actually press ahead. And we have mentioned that we have covered AI and the risks that AI poses. We also dwelt on the issues which have to be addressed by engineers and healthcare workers. However, we have not covered ethical problems, and they will be occurring everywhere in automotive, in healthcare, and everywhere. What do you think, Mark?
We've already spoken about that. Indeed, this is a different dimension that we as technicians or scientists, of course, we may not take it seriously enough in the first wave because technology is ahead for us of that. But this is a necessary dimension, human dimension, ethical dimension in use of AI in everyday life. When a scanner scans a road or the environment, it may scan also other things besides just the road and its environment. And therefore, we should always keep in mind that those who collect the data gets approach to data, and they should have at least a clearly defined ethical code. This is a chapter to be discussed for sure. I welcome by that our next speaker, who will, I hope, beautifully describe the topic. David Černý is here, designated as a philosopher, ideal profession for our subject. Can we hear each other? Yes, I can hear you very well, which is perfect. So, could you make us acquainted with how ethics can play a role in our contemporary world? Thank you for the word. Good morning, ladies and gentlemen. I'm going to speak for about 25 minutes, which means that I cannot go deeper into problems. Let me speak on general level. In my presentation today, I will think over some problems of a general character, of AI, super intelligence, whether there is any existential risk. It will be just a short part of my presentation. After that, I will pass to an effort to state and show as well that AI is not the problem of itself, but it's rather use of AI which may be an issue, and our approach to it. And then we will try to define fields where ethical problems are topical, and again we will try to prove that it's not the problem of toxicity of AI itself, but it's the problem of the things that people sometimes use approaches that go beyond ethics. So this is the general framework of my presentation. And as I promised, I will start with what's being discussed very much recently, whether AI may be a threat. By the way, let me say that all pictures were generated by AI in my presentation, which is another proof that AI may be a perfect tool that helps us in many aspects. However, oftentimes, and it's due to the fact that the topic is very attractive, it's a buzz topic, journalists are sometimes attracted to state that it is a threat that can extinguish us. In our Western civilization, approach to technologies has been predetermined by our concepts of AI in sci-fi literature. There are many studies that show that. And it's interesting that in our Western society, AI is rather pessimistic in its different forms, robots and other types. AI is rather a line entity that is far away from human and ultimately may threaten or even endanger humanity and may even exterminate it. If you look at Japan, for instance, perception of technologies is very different. They do not perceive AI as a threat, rather as an intermediary helping people to mature and to maintain a good and a healthy lifestyle. So this is given by religious and cultural environment in Japan. In our country and countries, it's usually divided. There is human on one hand, and there is technique and technology on the other hand. And we do not realize that technology may be perceived as a very radical cognitive extension of us, humans. It enables us to process better information, to get a better understanding of the world, to overcome different physical obstacles and limits. So we may perceive it as something natural based on our knowledge. It can be definitely an extension of our skills that we gain during our evolution and that are very limited. So this very idea that AI may be the very last human invention, in the sense that when it reaches a certain level, it will take over the reign of the world and will not have the need to leave humans living here, it may be overcome. Until recently, AI was framed as this. Now there are new frameworks containing also different threats. We may divide them into 3 different criteria fields: the extent that is rather minimum, the extent that is more serious, or the risk that is really global, may cover a transgenerational transfer, which means that there will be no further generations, or their life will be so low quality, so deteriorated, that we will not consider it anymore as human lifestyle. These may be horrifying threats, those global and transgenerational ones. And those global and or transgenerational risks, they should lead to extermination of humans, to survival in only something as biological form, with no respect to human rights, with no respect to our diversity, and so on and so forth. In this context, AI is very perceived as a transgenerational existential risk, higher than climate change or any other risk. How should we cope with it? Scenarios are very hypothetical. Very often they are based on sci-fi, but the core is very simple. There is general artificial intelligence. There will be very soon super intelligence, and if this super intelligence is created, there will be also OUI, there will be explosion of more and more intelligent AIs. Another importance of singularity is that we will lose insight into a complexity of new devices and machines. We will stop being able to understand their functioning, and therefore this singularity represents a moment we will lose all control over our life and the planet. Why should AI exterminate humankind? One of the explanations is it will not like us, it will take us as a certain risk, and therefore it will exterminate us. But it doesn't need to happen. It will be far enough if AI solves tasks in which humans will be an obstacle to reaching the solution. David Russell said, we humans look at people with a lower intelligence with despise, and if there are ants and we build a dam, we will just condemn, we will just sacrifice ants. And something similar may happen with 2 humans in the future, that the AI will not take care of humans if they are in the way of solving some task. But AI should develop further tasks, and among them there should be protection of one's own existence, not for self-preserving instinct we humans have, AI does not have, but in order to be able to fulfill the final goal, which is to act in such a way that humans cannot switch me off. There may be different defaulted reaching the goals, so that AI arrange for human beings being happy through some specific vaccination. This is not exactly what people had in mind. Or if we charge AI to make clips for paper, and it will produce clips for paper for such a long time that it will destroy all reserves of paper and wood for humanity, and then it will go further for having material for these paper clips. So it will not act in such a destructive way that because it would like to do so, but it will continue this way because it will be programmed this way. So how much real is it? I don't think it's very realistic because we do not get to this level of AI. The systems we use already, the systems that exist today, such as large language models, are extraordinary, admirable. They may do a lot of things, but they are limited at the same time, and they are not able to overcome their limits done by their architects, by algorithms. And even if we create many systems that will control cars, that will make diagnostics, and so on and so forth, still these systems will be impacted or linked to given parameters given by humans, and it's difficult to imagine that they would be able of such things as to prevent people to switch them off. So there is a certain hypothesis that AI could get there could be anthropomorphization of AI in the way that AI could start behaving as people wrongly or correctly, but it doesn't need to happen. And one more example I have, these language models, they are very much written about now, and they are really fascinating. However, they lack all important things we connect with human intelligence. They do not understand the sentences. They do not know what they do. They created that perfect statistical analysis between words, context, sentences, and based on that, they can give you solutions or answers. And it resembles very much to John Searle's experiment, a Chinese room. Several argumented against possibilities of strong AI that would have a conscious understanding of semantics, and he proclaimed that it has only synthetics, not semantics. Common AI does not need to be super intelligence. And his experiment, mental experiment, was that we have a room with a person that doesn't speak Chinese but has a perfect manual. And if you give him a sign in English, he's able to connect the sign in English to a sign in Chinese. And it looks as if the room understands Chinese, but there's no comprehension of the symbols. These language models are very much like that, with the difference that we have given them certain rules. No, sorry, we haven't given them certain rules. It's the AI that created the rules itself based on algorithms. But in parallel with this Chinese room, there is no understanding, there is no motivation, there are no intentions. Let's continue. What I am much more intrigued by, and what I like much more in discussion about intelligence and superintelligence, is that it takes us away from real problems that are current problems needing our solution. We are surrounded by many systems of AI that have a basic impact on our way and living standard, and therefore they decide about how we will further develop, and we are not able to keep pace with them.
Well, the real issue, as I see it, is our passivity. That means we are not flexible enough in responding to the risks when we have more AI systems, including the shortage of AI knowledge. In schools, we have failed to adapt the curricula, so people don't know about the limits of these technologies. They don't know how to use them correctly, and that can influence negatively our thinking. Another trend, which is not a very positive one, is that we speak about liability or responsibility of AI as if there were any. I would say humanity is supposed to be responsible or liable for things that happen, and that's why we as a society should create a responsibility culture in which such systems will be developed and devised, designed as good and actually nurturing for the humanity. Well, ethics in AI, there are variant documents. This is actually a document from a group of scientists and it says that AI should actually abide by laws, should be ethical and reliable. And we speak about autonomy, about fairness, about actually clarity, about harm. Well, of course, these principles have got their limits because, of course, they came from various experts who have got various actually opinions. But there are various systems of some intelligence degrees, but every system has got actually different tasks. So a better approach would be to consider a specific system, let's say autonomous driving or telemedicine or military robots, and address the issues in those specific areas. And let me pinpoint some issues which we battle nowadays and show you how we actually get involved by AI. Well, we have been speaking about the so-called pandemic of bad thinking. People are actually not able to think critically anymore, to categorize knowledge or information, to verify, validate it. That means this system of critical thinking has been actually somehow damaged, and people actually believe disinformation, false information. And AI plays a role here, but there are mechanisms that actually strengthen this trend, and these are those bubbles, as you see on the slide. There are algorithms which actually spew those bubbles, information bubbles, and they actually distribute information in those bubbles, and people are exposed to those individual opinions, and people then believe it. Very similarly, there is another image showing that algorithms actually connect us with people who have very similar opinions, and they might be actually false. And artificial intelligence actually boosts these trends, but it is not the main culprit. It's the human being who should use critical thinking. Another issue is that artificial intelligence is gonna take all work and will replace us at work. It might be true, but only partially. It depends on the job we have. For many of us, we go to work because we need money to be able to cover our needs. And for many people who see it this way, it might not be a tragedy if they actually are replaced by AI, and that does not mean that they will stop working. That means that they will actually change jobs. They might actually lead some extracurricular activities or some clubs. They might actually do their hobbies and do something that they like. If we find out how to feed them, it could be a nice reality. So you see this picture here on the slide. If the robots do our work and we know what to do during that time, then it is fine. It will depend on our society, whether the problems related to the shortage of work is not contributing to the gap between the rich and poor. Another issue I would like to speak about is democracy. We have got empirical studies showing that democracy is not working as it should. It doesn't mean that you go and vote. This is a formal element, but of course there is more to it. That means that people should participate in government, in public administration, and people need to be active. And those empirical studies or research show that people don't read the agendas of political parties, the manifestos. They are not interested in it. It's more emotional, the relationship. And of course, once there are global challenges occurring, we need more knowledge. And AI is used and can actually prepare populist speeches, and the speeches will be perfect and reach out to the audience. What I found out that Barack Obama used that. I was actually surprised that they actually prepared the speeches for him so that he is liked by his audience. So that could be also an issue. Another risk posed is as follows. AI might, of course, identify threats, but at the same time, we are being watched. We actually are present in social networks. Once we buy something, we buy some robotic tool, then the data is gathered. This doesn't need to be a problem, but what if governments use it en masse? In China, that is actually happening nowadays. And that means that we are a private entity and we want to actually speak about private thinking also. And such systems watching us could actually endanger our freedom. And now I'm not speaking about direct threat by AI. I'm speaking about misuse of it. Military robots. This is technology that is not spoken about so often, and this is something that is developed all the time, and there are so many ethical problems, so we shouldn't forget about it. Another example would be this system Compass, which can predict the probability of somebody relapsing if a criminal actually repeats his crimes. And of course, it can work statistically, but not individually. And that is why we should never use AI for this area, for this issue. We know technology works, but we know that technology is not aligned with our values, the values of our society, so we should not use it in this area. Well, in conclusion, I'd like to say that future is in our hands, and the relationship between a person and technology has been perceived antagonistically, but we should speak about co-evolution. That means AI will be evolving next to us, next to humanity, and of course we will see cyborgs developing to some degree, and this evolution might be exciting and might be actually mutually beneficial, but if it backfires, then it will harm humanity. And my last slide is here. What I've read is that GPT 3.5 wrote that people are afraid that AI will exterminate us. And he was encouraged to write some positive message. And this is the message. Of course, I would like to pacify people who are afraid of AI, but you have to see that AI is a tool which can be used for good and bad purposes. And how AI develops in the future will depend on people and their values. And that's why don't lose hope and be active when developing the future with AI. We have the opportunity to use AI for addressing climatic change, healthcare, or new industrial areas, and that's why we should try to create relationship between people and AI. Thank you. Thank you so much. That was so inspiring, this presentation. And now I want to mention some comments online saying that AI wants to make us happier, and that's why they actually contribute to us being more stupid, less educated. But I would also like to ask about challenges. So what challenges do you see in education as a system? Challenges, okay. Okay, what I think is okay, thank you. Well, the challenges are unfortunately we cannot hear the speaker. Bohužel tlumočníci neslyší. Je velmi špatné audio. Není slyšet. Tlumočníci nemohou tlumočit. There is some technical glitch. The connection is breaking down. So we will see whether we manage to get you back. I hope it's not AI actually interfering with us. Can you hear us? Okay, yeah. Yeah, there was some disruption.
Let me say it very shortly. The AI shows that we have to orient education on critical thinking. And of course, the noise quality is again very bad. There are limits. We apologize for technical issues. We somehow cannot control, but you can raise your questions also subsequently. As far as I look at the questions, many of them went into very depth of the subject, so you can contact the speaker. And at this moment, I would like to thank all our morning block speakers. We will continue after our break. And still before the break, let me comment slightly, or let me say some more thing.
We will first draw the lucky winner of the first prize, and we have an application that completely randomly chooses one of you who have registered for today's conference, and that will be the winner of the first prize. The principle is that there is a sort of a gun shooting away those that are not that lucky, and who remains and not be shot by the gun will be the winner. You can observe the number of remaining participants of today's conference who have participated in this sort of game. And as the number is getting lower, we are heading towards our winner. So we have like 10 remaining persons. Now, you know, this probability of shooting persons is getting low, so we have 3 remaining ones. And we are getting close. There are just 2 of them. So who will be the unlucky and who the lucky one? Oh, I see. So here's the winner. There is no need to do anything. You will be connected by our team, and the person who will connect you negotiate the way to exchange the prize. Thank you very much for viewing this morning block, and we will follow to the break. But before break, let me notify and let me remind once more that answer few questions, simple question on this reference, and you can be the winner of the cell phone for the next drawing. Thank you, and let's start the break for 25 minutes.
See you.
Unicorn University jsem se rozhodla studovat, protože se mi líbí, že propojuje obory, které jsou mi blízký. Já pracuji v marketingu české internetové jedničky, takže propojení IT a marketingu bylo něco, co mi hodně dalo, protože jsem se naučila to, jak lidi v daném oboru přemýšlí, fungují, a naučila jsem se něco i o obecně technologických projektech. A tím, že spoustu vyučujících bylo přímo z oboru, tak bylo mnohem snazší potom do praxe rovnou přejít. A taky bylo fajn si navnímat, že vlastně monitoring a příprava a různá analýza dat je potom dost klíčové při dalším rozhodování. Nejvíce mě bavila podniková ekonomika. A bavilo mě to proto, že jsme pracovali na konkrétních casech nebo datech, které jsme si získávali různě z internetu nebo jiných dalších zdrojů, takže to bylo aktuální a zároveň hodně kreativní. V rámci výuky si myslím, že je velký rozdíl mezi tím, když studuju na jiné vysoké škole, často je to velmi, řekněme, teoretické, možná i pasivní. Tady se mi líbilo hodně aktivní zapojení studentů a vlastně reálná praxe v konkrétních workshopech nebo zpracovávání i dat, které vlastně jsou běžně na trhu. A během studia jsem pracovala, učila jsem na střední škole, takže to bylo poměrně náročné, ale pokaždé se mi podařilo najít hodné termíny pro přednášky nebo zkoušky. Jednou jsem dokonce využila i individuálního termínu, což bylo super. Kromě hlavních předmětů ve škole se mi líbilo to, že jsem mohla zdokonalit své dovednosti v řízení menších projektů, komunikaci a taky sdílení know-how s lidmi z oboru, kteří byli zapálení do všech projektů, na kterých pracovali a naše kontakty jsme si udrželi i po ukončení studia. Studium na Unicorn University bych určitě doporučila, protože velmi dobře pracuje s propojením teorie a praxe, protože se pracuje na různých reálných datech a studenti si tak můžou vyzkoušet nějaký konkrétní příklady. Vyučující jsou velmi často z oboru, takže mají i užitečné rady a situace, které mohou nastat, což se v knížkách nepíše. Na Unicorn University bych se určitě znova přihlásila, protože mě hodně bavilo pracovat na všech projektech a vás to bude určitě bavit taky.
Ahoj, volám sa Jana Tatarková a v Unicorni pracujem ako manažérka predaja pre oblasť bankovníctva. Pred 12 rokmi som nastúpila na pozíciu junior analytičky. Bola som čerstvo po škole a mala som zmiešané pocity a neistotu z nového pracovného prostredia. Moje obavy sa rozptýlili hneď v prvý deň, keď som vstúpila do kancelárie. Dýchla na mňa skutočne priateľská atmosféra a privítal ma tím mojich budúcich priateľov. Nejakú dobu som bola jedinou ženou na projekte, čo so sebou nieslo mnoho výhod, ale aj nevýhod a hlavne veľký rešpekt k ostatným kolegom. Som veľmi rada, že v Unicorne dnes pracuje viac ako 30% žien a že sa toto číslo konštantne zvyšuje. Počas 12 rokov som mala možnosť prejsť si rôznymi pozíciami, tak v oblasti testu, analýzy, ako aj manažmentu. Pracovala som na rôznych projektoch a aj preto som nikdy nemala pocit, že je moja práca statická alebo nudná. Unicorn je pre mňa niečo ako rodina. Ako náhle sa stanete jej súčasťou, viete, kam patríte. V Unicorne stretnete mnoho skvelých a šikovných ľudí a dostanete príležitosť rozvíjať sa podľa svojich preferencií.
Potěšením zahrát na vaše vypečené večírku.
Přátelé, já jsem strašně rád, že jste všichni tady a věřte mi, že uděláme všechno pro to, aby se vám to dneska líbilo.
To nejzajímavější, co jsem se na Unicorn University naučila, je schopnost řešit komplexní problémy a učit se v IT oboru, protože je to trošku specifické. A zároveň Unicorn University poskytuje systém vyučování, kde máme hodně praktické výuky. To znamená, naučila jsem se řešit podobnou problematiku, tak jak bych potom řešila v praxi. Tak a vlastně hned během prvních 2 semestrů jsem se naučila ty nejdůležitější hard skills, to znamená programování v Pythonu, v Rku a v SQLku spolu se základy statistiky. A potom už vlastně člověk potřebuje jenom svoji vlastní píli. A já jsem díky Unicorn University měla možnost dostat se vlastně na pozici data scientisty v Centru umělé inteligence pod O2. A to tím způsobem, že jsem jako své portfolio použila své seminární práce, které jsem měla vypracované právě ze školy. Studijní materiály považuji za jednu z největších výhod vůbec studia na Unicorn University. A to z toho důvodu, že je máme k dispozici vlastně neustále, jsou online a můžeme je používat při cestování, přesně tak to dělám já. A zároveň nám šetří čas a energii, nemusíme si nic zapisovat a můžeme tu energii věnovat rovnou učení. Studium na Unicorn University bych doporučila z několika důvodů. A jednak máme mod Work and Study, který je příznivý pro všechny, kteří přes den pracují a nemají čas zúčastnit se normální prezenční výuky, ale zároveň jsou zde velmi ochotní učitelé, kteří jsou vždy na vaší straně a snaží se vás podpořit a věnují vám svůj čas vlastně nad rámec výuky. Jednou z nejdůležitějších věcí, co jsem se u nás ve škole naučila, je komunikovat s více technicky zaměřenými lidmi a celkově spolupracovat ve skupinách. A na jednom z hackathonů jsme řešili například programování hry a programovali jsme miny. Pokud se chce člověk věnovat data science, tak si myslím, že Unicorn University je perfektní volba. A právě díky tomu balíčku základních dovedností, které nabízí v poměrně brzkých semestrech, to znamená v prvním a v druhém. A taky je to škola, která je otevřená lidem, kteří přes den pracují a dokáže se přizpůsobit. Zkrátka je to tady super. Tak se přihlašte. Dobrý. Tak děkuji.
Unicorn is a renowned European company providing top-class enterprise IT systems, products, and solutions. We have been delivering IT solutions for the energy industry for more than 25 years. We had come up with one of the first energy market management solutions in Europe when the liberalization of the European energy market started. Later, we introduced ETRM products to our portfolio, which serve as top-notch tools for energy traders of all kinds. And now, we significantly contribute to the green transformation of the European energy sector. Our products and technology ensure energy balancing, security of supply, transparency, and sustainability on the continental scale. The European energy market is now on the verge of transformation. Fossil fuels are on the decline, being replaced by renewable energy sources. In electricity generation, the number of controllable traditional power plants is declining, whereas the share of intermittent solar and wind is increasing. Electrification of transportation and heating brings even more stress into the electricity system. Energy storage and load flexibility are therefore essential to maintain the security of the electricity supply. That is why we focus on solutions bringing modern appliances, such as home charging stations, battery boxes, or heat pumps, into play, engaging them in grid balancing and letting their owners profit from energy transformation. When we look at our product portfolio from the top level, our platforms power most of the pan-European and regional markets. Our software joins the power markets on long-term, day-ahead, and intraday time horizons. We have built two major European-wide balancing platforms, Terra Libra and Mari. In the Nordics, our Damas organizes the regional capacity markets and settles all electricity trades in the whole region. Our Damas platform stands in the core of energy markets in 19 European countries, organizing the international energy markets. In addition, we have our Certegy products, which manage the whole life cycle of green certificates, making sure that end customers consume the energy from renewable sources and renewable energy producers receive an additional income. Lancelot platform-based products cover the level of electricity trading. It provides complex support for energy commodity trading. Lancelot is designed for energy commodity traders, suppliers, and distributors who appreciate its technological edge and advanced prediction and optimization functions. At the last level, a new group of market actors arises, the flexibility aggregators. For them, Unicorn has introduced a new product line, Flexigy. Flexigy is an energy flexibility trading, optimization, and management platform that allows to aggregate smaller distributed power resources and controllable consumption into tradable blocks, so-called virtual power plants. Flexigy controls cogeneration units, batteries, photovoltaics, hydropower plants, as well as assets with adjustable energy demand, like industry freezers, HVAC, or EV chargers. When it comes to flexibility from EV charging, Flexigy works best together with our ChargeUp product, a complex solution for e-mobility. Flexigy allows you to maximize profits from your energy assets and turn the energy transformation to your advantage. All of these products and solutions are built using our standard mobile-first, IoT-ready cloud architecture. The architecture allows us to deliver technologically advanced, reliable, scalable, and highly secure solutions quickly, cheaply, and with minimum risks, while working seamlessly together. With our products, we mobilize the potential of all energy assets and make them actively participate in the energy market, resulting in additional revenue streams for our customers and vast reductions in CO2 emissions. In Unicorn, we believe that a sustainable energy system is one of the keys to make our life on Earth better. Unicorn is an expert in energy trading. No matter which role you play in the market, we have a perfect solution for you.
Já bych Unicorn University doporučil nejen z toho důvodu, že vnímám, že hodně propojuje jakoby business s tím studiem, že to není jenom o naučení se skript a odříkání u zkoušky, ale vyloženě i ty praktické workshopy, které vlastně máme, tak nás učí nejenom komunikovat s lidmi, ale taky vlastně připravují nás jakoby na ty pozice samotné. Absolvoval jsem 2 workshopy. Například máš jako zadání nějaké neúplné firmy nebo firmy před nějakým krokem, který musíš jakoby projít, vyřešit ho a přijít jakoby na ten správný styl, jakým by se ta firma měla ubírat v celém portfoliu nebo na celém tom trhu. Já, když jsem vlastně nastupoval, tak praxe ještě nebyla povinná pro to studium, ale i přesto jsem vlastně využil možnosti jít na stáž do společnosti Microsoft, který je vlastně jednou z partnerských firm Unicorn University. Už během té stáže jsme se vlastně nějakým způsobem komunikovali na tom, že by mi to třeba dávalo smysl jakoby se tam posunout dál a prošel jsem si výběrovým řízením, které v Microsoftu je a dostal jsem se vlastně až na pozici, kde jsem dneska. Tak studijní materiály ty máme jakoby online. Všechny jsou jakoby na portále přístupné vždycky z předmětu, který studuješ. Myslím si, že pokrývají vlastně všechno, co je potřeba k tomu, aby si ten předmět zvládl. Samozřejmě vysoká škola je od toho, aby si z některé podklady našel i sám, ale tady ty podklady jsou hodně připravené na to, aby si tady tuhle práci skoro nemusel dělat. Takže za mě studijní materiál je super. Co se týče vstřícnosti ke studentům, myslím si, že vždycky si někdo najde své mouchy, co mu vadí, co mu nevadí, ale tady si myslím, že se odvádí skvělá práce a to už bylo moc marketingové.
Pro řešení dobíjecích stanic v komerční bance jsme vybrali ChargeUp od společnosti Unicorn. Rozhodli jsme se proto, protože jsme hledali silného partnera, který by byl schopen nám dodat komplexní dodávku, to znamená stavební připravenost, hardware i software. Výběrové řízení bylo poměrně dlouhé a náročné. Ty kritéria, aby jsme vybrali tu správnou společnost, bylo poměrně hodně, nebylo to jenom cena, ale byly to samozřejmě reference, byla to rychlost dodávky těch dobíjecích stanic a zajímalo nás, odkud jsou vlastně dobíjecí stanice. Chtěli jsme se vyhnout nákupu čínských komponentů a tohle společnost ChargeUp splnila. V současné době už máme vlastně dokončenou lokalitu Stodůlky a během pár týdnů dokončíme i další lokality jako Václavské náměstí a Libohošť.
V rámci projektu jsme instalovali dobíjecí stanice španělského výrobce Sircontrol. Celkem se jedná o 84 dobíječek v první fázi projektu, a to ve 3 lokalitách. Všechny dobíječky jsou o výkonu 22 kW a jsou takzvaně chytré, to znamená, jsou připojené prostřednictvím internetu do našeho backendového systému, který Komerční banka používá pro aktivní monitoring a dohled nad provozem dobíjecích stanic, jejich vzdálenou správu a řízení. V rámci navazujících etap projektu počítáme s integrací backendového systému ChargeUp CPO s dalšími systémy Komerční banky, například s fleet managementem nebo systémem pro rezervaci a vypůjčování elektrických vozidel. Systém bude rovněž přizpůsoben Komerční bance z pohledu jeho grafického vizuálu, bude obarven do barev Komerční banky, vybaven logem Komerční banky, a to platí rovněž i pro aplikaci pro koncové uživatele ChargeUp ESP. Tu budou elektromobilisté Komerční banky používat pro aktivaci dobíjení a pro sledování stavu dobíjení služebních vozidel. Komerční bance jsme dodali komplexní řešení pro dobíjení elektromobilů, to znamená od návrhu projektové dokumentace až po instalaci dobíjecích stanic, připojení do řídícího systému a následný monitoring a provoz dobíječek. Kromě toho jsme k dispozici 24/7 na telefonu, to znamená, pokud bude mít kdokoliv z Komerční banky, ať už obsluha backendového systému nebo řidiče elektromobilů, jakýkoliv problém, jsme jim k dispozici. Těšíme se na další etapy tohoto projektu, protože spolupráce s Komerční bankou v elektromobilitě je naprosto úžasná.
Prioritou Komerční banky je být uhlíkově neutrální od roku 2026. Činíme poměrně hodně kroků, aby jsme dokázali k této neutralitě dojít, a elektromobilita byla jednou z klíčových věcí, proč jsme se rozhodli jít vlastně touto cestou. Byly velké diskuze o tom, jestli jít plně elektrickými auty nebo hybridy. Nakonec jsme se rozhodli jít tou cestou plně elektrických aut právě z důvodu toho, že chceme být uhlíkově neutrální. Tady na střeše ve Stodůlkách budeme stavět fotovoltaickou elektrárnu. Vize je taková, že do roku 2025 chceme mít všechny auta, které máme k dispozici v Komerční bance, elektroauta, což znamená, že bychom měli v těch následujících letech pořídit cirka ještě 400 aut a samozřejmě dovybudovat ještě 400 dobíjecích stanic. Věřím, že cesta, kterou si vybrala Komerční banka, je správná a bude inspirací pro ostatní společnosti být uhlíkově neutrální.
Vlastně spojení Unicorn University s Unicorn jako holdingem Unicorn je velkou devízou celé školy, protože studenti získají zkušenosti z reálné firmy, s reálnými projekty, s reálnými zákazníkami. To je velká výhoda vlastně oproti normálním státním školám, kde většinou studenti si musí hledat praxi sami. Po vystudování Unicorn University jsem se vlastně přestěhoval do Spojených států s cílem vyvíjet software přímo v Silicon Valley. Zkušenosti, které mi Unicorn University poskytla v rámci praxe a v rámci výuky, mi pomohly získat mou první práci v Americe. Když jsem poprvé vlastně chodil po pohovorech ve Spojených státech, tak jsem si připadal, že jsem, jak Američani říkají, up to date. Technologie, které byly zde vyučované, byly nadčasové, byly používané v reálných firmách. Zkušenosti, které jsem zde získal, ať už je to bylo se základy algoritmizace nebo s metodikou práce, byly také aktuální. A když jsem chodil po pohovorech, tak jsem se cítil velice jakoby silný kandidát, protože jsem měl reálnou praxi. V rámci studia na Unicorn University jsem byl schopný získat pozici softwarového inženýra v cybersecurity firmě, kde jsem strávil 5 let na různých pozicích, ať už jako softwarový inženýr, anebo produktový manažer. A později jsem se přesunul do firmy, která se jmenuje Automotive, což je v podstatě dneska největší cybersecurity firma a kde pracuji jakoby product line manager, kdy vlastně já převádím zákaznické požadavky do požadavků na produkt. Studium na Unicorn University bych doporučil z toho důvodu, že Unicorn University je součást Unicornu. Lidé, kteří jdou do Unicorn University, budou expozováni reálné firmě, reálným procesům, reálným lidem, kteří každý den pracují se zákazníky a řeší reálné problémy. Jedna věc, kterou bych rád podotknul, je, že na Unicorn University jsme měli vlastně přístup k veškerým školním materiálům po celou dobu studia v online formě. To bylo velice důležité. A veškerý materiál byl také ve videoformě k dispozici na školním systému, což bylo také velice důležité, když si člověk potřeboval něco zopakovat nebo refreshnout. Já bych doporučil jít na Unicorn University, protože v rámci studia získáte praxi a budete pracovat na reálných problémech s reálnými zákazníky. Po vystudování nebo po absolvování Unicorn University nebudete mít žádný problém získat uplatnění nebo získat práci v jakékoliv softwarové firmě.
In Unicorn, we believe that the renewable energy certificate markets are on the brink of a change. The increasing customer awareness and demand for sustainable energy will drive evolution in areas such as granular certification with 24/7 matching, hydrogen and other new energy carriers, energy storage, or full disclosure. Ultimately, this will lead to massive increase in traded volumes of green certificates. We believe that the current way of operation must change, as it is difficult to scale and prone to errors. Nowadays, trading companies use various ways of communication to conclude deals, use many different ways for confirmations with counterparties, store data in multiple tools, and manage certificates and settle trades across many registries. Certegy Trader is a tool to address this challenge. Our goal is to simplify energy certificates trading as much as possible, from the moment of deal confirmation to final settlement in the registries. Certegy Trader is designed to work as full-fledged standalone trading solution or to work in parallel with any current ETRM or other solution in use. The main features of Certegy Trader are forecasting, trade capturing and confirmations, portfolio allocations, position reporting, and automatic settlement in many registries. All the features are optimized to work with high volumes of certificates with resolution up to 1 hour. User experience was designed in cooperation with certificate traders to bring maximum user comfort and efficiency. The trades are captured either via a few-step form by bulk import or via API. All attributes and details from the REX International Contract Template are supported. The allocation of trades is simple. Just choose what you want to allocate using various parameters of the trade, and Certegy Trader will make sure that all criteria of the allocated trade are respected. You can browse your portfolio as necessary and create customized views and dashboards and share them with your team. Certegy Trader is built by Unicorn, leading European provider of IT solutions and services in the energy domain. Certegy Trader is provided as a service in the cloud, operated in Plus4U ecosystem, and hosted in Microsoft Azure. The setup of the solution is easy and can be completed in a few days. Get in touch with us and ask for your free trial today.
Na Hečeri ma zaujala príležitosť stretnúť sa priamo s pracovníkmi z Unicornu.
Chcela som niečo, kde by som sa mohla viac angažovať a nejak ukázať svoj potenciál a toto vyzeralo ako fakt skvelá príležitosť nejako sa ďalej posunúť.
Setkal jsem se i ze spousty kolegy, kteří Hečery prošli a zmiňovali, že jim v kariéře velmi pomohla.
Během školení jsem se naučil spoustu nových dovedností, zejména jak navrhovat aplikace v Unicornu úplně od začátku.
Zo začiatku sme na predstavuje celkovú spoločnosť, ako to v nej prebieha, aká je vlastne kultúra spoločnosti.
Následne sa prešlo na tie design.
Good morning for the third time already. Welcome again to our conference dealing with artificial intelligence and now focusing more on GPT-3, which is an instrument that is not used only for some amusing intentions. It's something else. It was an, let us say, wow moment, iPhone moment, a new technology on the scene. And the usage of ChatGPT now interviews all the different fields. And I presume that Josef Šlerka will show us also other usages, not only generating essays for school or drafting newspapers articles. There's a lot of work behind larger language models and corpuses. I'm very happy we have Josef Šlerka among us from Charles University. He will tell us something more about the topic. Good afternoon. Let me welcome you to a lecture that was first titled Prompt Engineering or Prompt Wizard. And some thought I designated myself Prompt Wizard or Prompt Engineer. So we renamed the lecture as Condensed Introduction to Prompt Engineering, Applied Theory of a Garden where paths fork out, or Dr. Strange and his concepts. Let me first speak about what are large language models, how do they work. It will not go into depth. It's rather proposing you an alternative that will help you to understand what's inside such large language models. Then I would shortly speak about so-called prompts, continuing with strategies in generating texts. And since we are in this complex world of IT, we will also speak about prompt engineering, what is programming and such, and what's the future of it. The topic is large. Large language models. This is from Midjourney. Human head and face with these language symbols. The picture is not incorrect if you think of it. A large language model, this is an AI trained on a large amount of text data, resulting in a model that generates a natural language text. Most often we meet such models and GPT-3, BERT, or ChatGPT, which are names for different types of models belonging to the same category of models, or sometimes they are just different versions of the same model. What idea should we have of it technically? On technical level, it's in fact a neural network that learns how to complete continuation of a given chain, which in our case is a text, but it can be a chain of different type. And the network, based on a large amount of data, tries to find the optimal internal configuration so that it becomes able, if you give it 3-4 tokens, that it is able to say highest probability of this conjugation, middle probability, low probability of continuation of that type. It's been trained on large data sets. Popular statements say that it contains all internet. We know that in model of GPT-3, Wikipedia created a large amount of the data contained, but the concept or the idea we have of it is that it's sort of a whispering instrument. If I remember older telephones with the program T-Knife, you wrote a message and the software was able to complete your sentences. This idea is not completely incorrect because it does something similar, but behind that there is something more scary, and it is that it gives an idea that you can see all, and it's not true. I will offer you a different alternative, a garden with a forking out paths. It's paraphrases of a short story, Vorgese, 4G Genesis. We will speak about it in some other lecture. It's about the existence of a book that had different stories inside, and at a certain moment these stories could continue in different ways. One chapter is, for instance, about a man. In the second chapter the man doesn't exist, and in the third chapter the same man is killed, and the reader wonders what path to undertake. And our language models are something similar. You have a large garden where at every cross point there's a certain probability what direction you will take to get to the next cross point. And at the next cross point, again, there are different options, and you choose one or the other one depending individual probability. And if you came from one direction, it gives you high or low probability how you will continue at the next crossroad. So in principle, it's a large probability space where the levels of probability change depending your behavior. It may sound strange. That's why I have another parallel, and this is Dr. Strange in the Marvel series and his foolish universe world. People exist in different forms, and Dr. Strange moves among those parallel worlds and finds out that things could have developed differently. This is, in fact, a large linguistic model. GPT-3 is nothing else than an enormous generator of many different parallel worlds in which your behavior determines how the evolution will continue. This is the most important message you should take from this lecture. Why? Because in such a world, because this world is not of the type that software works as some graphic chart. This world is not that it is a smarter Wikipedia. It is not a world of existing statements the system has learned correctly or incorrectly. This is a world where several levels coexist depending on previous development. The fact that it understands you is explained by the fact that our language contains some information about the world. Whether the system knows something, it's a tricky question, but we can use Honza Kuwait's parallel. Imagine Platon's cave, people speaking about reflects of shadows on the walls of the cave, and in another cave there is an alien creature listening to people and trying to learn their language. I mean, to answer their comments or questions in the way they do. He doesn't see the people, but he tries to learn the way people communicate. And in a way, it's learning probability of further development. Our case is more difficult for the fact that this complex neuron network doesn't remember the things. It works as a certain condenser of things it encounters, and based on that, it remembers. If I simplify it, if an entity sees repeatedly a series of tokens, of figures, and there is some symbolic token that combines the individual ones, it's easier to create one's own agent being able to complete it. These are emergent. This is the theory of emergence. Something programs or systems can learn by themselves, something else than they've been programmed for. In practice, it means that we do have a model which at the beginning is blind and deaf, just exists, but we know that by training it, we can teach it by introducing inputs, which are chains or series of tokens, and by doing that, we can get some output. And alongside, we create a nice GPT chatbot, but it could be at the same time a very unpleasant or brutal Caligula emperor type of entity. You could train the system for this as well. So the difference between GPT model and what you see in the form of ChatGPT is just continuation alongside the chain you entered. I use now a Czech poem that says, I know a crystal well where the forest is thickest, where dark ferns grow and red heather grows all around. So there is otherwise silence, and there is evening dark, heavenly glow everywhere. So this is something that represents different worlds that end up at the border of this beautiful garden. You enter the space by having written the text, which meant for the system that some paths will be very little probable, while other worlds, where the parameters of the world may be much more probable than previous ones. And it brings us to prompt. Prompts are introductory text or series of tokens. They determine orientation or direction and context for the generated text. This is a path in the garden you want to walk up, and in principle, these are inputs into a model that determines probability.
And why are they important? Because they influence what you get. The model answers according to your request. And that means if you speak in simple sentences without any context, then you will get a very general answer, and that is logical. Prompt is a way how to lower entropy at the beginning of speaking with it. Prompt is the way to get the output which makes sense, and it is a way to stop in the garden and think about where to go. This is your bearings. And it doesn't matter whether it is a question or a statement, because it's not only about the question mark that makes it different, but it is very important to play roles, because this is how we actually give the command to activate a world. And that's why prompts are products which show what is in it. We know the jailbreaks that actually persuade the system to actually go on in the way which we prefer, but there are also glitches in the system because sometimes the system doesn't know how to repeat it. But because prompt influences the direction of generating, then tones are important, timbre is important, synonyms selected are important. And that is why when we create prompts, we should stick to the rules we use when speaking to a student who has got an issue with his memory. He will remember what you are speaking about. He knows very well what he learned right at the beginning, but he forgets what you discussed with him yesterday. So this is a person who remembers 10 questions you asked him. He doesn't remember what you discussed yesterday. It's Chat GPT, right? And then he remembers somehow how to generate the rest. So you have to tell him what you want, who you are, what the context is. And the best thing is to describe the answer you request. You do not ask him. You are an author and you are actually examiner examining a potential student who wants to study at a college. And if you actually give him or her a very too general task, then you will get a very general answer. If you have geometrical objects on a piece of paper and you ask him to name them, then he will say Jog, Jim and Jenny, and that makes a sense too. But what does it mean? It means that the system has read all print produced worldwide. So you should actually optimize, you should tweak the system, you should actually play with the structure, change the tones and timbre, and then you will see how the result will change. If we have a system in the work, in the way how we generate the tones, how we iterate, how we ask, how we don't ask, that is all included in the prompt engineering. Prompt engineering is a series of strategy how to optimize the orders which we give to the model. And what do we need for it? We need to be clear in asking, in describing the context, in describing the connotations. I understand that IT people might have an issue with it, but this is not a programming language where for each is always for each and nothing else. Experiment. Don't be happy with the first answer, and it is a simulator, don't forget about it. And in ChatGPT, you know that they are supposed to be creative. So sometimes you get different answers. So ask 10 times and then look for similarities between those 10 answers. Examples of actually best practice. Describe how sunflower actually grows, and be clear and concrete. So is it programming? I think it is. We can actually say that prompt engineering is programming, but it's not intuitive, and it uses natural language, and there are some things that play a role. In conventional programming, we need clear, unequivocal referencing for the code, regardless of whether it is Monday or Tuesday. Unlike here, where the language is so ambiguous, connotations, timbre, and somebody told me prompt is very important, as important as the answer. Of course, it is true, because this is how we actually lead it. It's, well, the input is not equal to the output, but don't forget it is a simulator, so we have to ask a lot, we have to change roles, and then we actually have to describe the whole space. And here we see the development of framework of latent chain. That means now we attempt to give external information to AI, and the book by Hofstadter will be useful for this context, because this is how our conscience, how our mind works. So, what can we expect in the future? Well, I'm happy I don't need to describe labor markets and other things. I think that we will only speak about high-level languages for prompt concepts. This is what we will see. We will see prompt lungs that will give us the possibility to program. So you will be working with variables, you will be actually creating the loops. This is what you are used to, but you will also search the probability spaces, the simulation, and it will open possibilities for the client research without communicating with the clients, because you will have simulations of various types of clients, and then you will be able to test various responses. And why do we expect this arising? Because we will need abstraction, modularity, flexibility. We are creating templates, and this is the prerequisite for this development. In conclusion, well, I tried to actually offer some parallels and tried to search for the way of a strict description of this probability system when we have a matrix and a sentence that it is how it could develop in a near future. And I hope that you will find some gravity in my lecture. Thank you. Thank you for your lecture or your presentation. And I, of course, have some questions, but you mentioned something about the prompt lung and ways how to branch out. So could we test some branches just for the experiment per se? Well, we work with it and we have got projects, and there are projects with simulators, and they are really exciting because you can actually create a series of or set of various worlds, and that seems to me the most exciting way. And how about actually going in the direction of prologue? Yeah, prompt lung is a synthetic way, and I have realized that that generation 6 say Prolog and SQL is coming back. On the other hand, the managers will never have taken the data themselves from the databases. But what I want to say is that people are not happy about formalistic approach. Sure, yeah, so let me ask you something different. We were speaking about the number of tokens and about ChatGPT, and this model, there are actually some books about it, etc. There are some things in Wikipedia. So what made ChatGPT so popular? Well, it's about the probability distribution and about the capacity to comprise it. So this is a compression algorithm. That's why we said that it was a JPEG of the internet. Well, I don't think this doesn't work really as a description. You see some representations there in Google, and of course there is some role of it, of the corpus of the body, and now we will see what they will be able to mine from the autonomous systems. But in terms of ChatGPT, what was the most successful feature, or what was the ultimate success, was that ChatGPT was created without the worries that, because you have of course so many technological companies, tech companies, and if you are an established company, you cannot actually come up with something which has got glitches. But if you are a startup, you can actually use the approach of learning by doing. And that was the reason, the root cause for success, because they, the developers, were not afraid of making a mistake. That's why. Well, this is an approach, right? Well, it is. It's not very academic, it's not very business-minded, but that was the atmosphere of the developers. Well, this is a good piece of news, especially for those who work in their garage. Yeah. And I have to say that 1,000 of people have survived and the rest won't probably. Okay, there are those prompt things here up and running. So how would you describe the market, please?
Yes, that's why I mentioned chain and the other phenomenon for language processing. Now we are at the stages of impressive growth, and we will see different development in a couple of years. I suppose that in quite a short time, we will see how the systems will be able to stabilize themselves. So there will be a big hype around automobiles, independent automobiles. There will be motivation for academia because this is in fact an environment where AI focuses is very much debated. There are some minor chapters, as for instance, the reproducibility of research, which is useful when you have a security company. Reproducibility is important, and when I promised a long time ago to write something about it, and I haven't done it yet. I'm just joking. Anyhow, it got a bit older, and we also run out of time. Thank you very much for your presentation. I thank you for the invitation. It was a perfect contribution to today's debate. And we will advance now.
You mentioned several markets, several markets as examples, but one of the market we were actually describing in more detail, and it was automotive. But another very important market that can highly benefit from adoption of AI is an energy sector, isn't it?
Yes, we are heavily involved there, and it's clear that AI and involving AI into those solutions will bring definitely the added value there. And I expect that we will be speaking here about the predictions and using such algorithms to improve the results of our technology and our solutions. So this is really a field with huge potential. We are doing great there, and I expect that in the next few minutes we will speak here about the progress in this field.
Okay, so I'm glad to welcome here Jaromír Šivic from Unicorn, speaking about all these topics.
Yeah,
please.
Welcome.
Hello, ladies and gentlemen. So let me pass you through this topic. So, brief introduction. My name is Jaromír Šivic. I work for Unicorn for over 10 years. Right now, mostly in energy sector, doing and developing, analyzing all of those IT solutions for transmission system operators, storages, mainly in gas industry, and as well for energy traders. So, as it was already mentioned, there are many energy challenges and innovation ahead of us. Some of them are imposed on us, basically by our policymakers. Others are enforced on us by nature. I'm talking about renewables. Everybody right now knows that there is just a decline amount of fossil fuels in the future, so we need to move that way anyway. There is a huge drift in the e-mobility markets nowadays, and our policymakers in Brussels make it absolutely clear to us that there is no other way around it. There are smart grids with smart meterings. We are talking about them for years right now, but slowly it starts to happen. So we have all of those informations from your appliances, and we are gathering those data, and those data will lead us to the new way of predicting environments, consumptions, and so on. And of course, there are many others. And let me put it this way. Let's make a long story short. AI will be and will play a major role in all of those fields. And I cannot imagine a field without AI in the future, because of that big amount of data we will gather from basically each and every corner of the energy sector. So right now, we are seeing already AI making its progress in commodity markets, mainly in algorithmic trading. It is already there, hopefully making big money, in short-term commodity prices forecasting, in consumption and generation of energy. I assume from photovoltaics, it's just the way it will happen, and we will go that way, moving from a standard traditional statistical models. And maintenance planning, again, we will move out from statistical models to AI driven by deep neural networks. And there is many more. I remember there were a lot of PhD studies about losses detections and theft for DSOs when I did a PhD studies. So if you are somehow stealing on electricity, I hope you are not, there is a high chance that the AI detected those losses and sent a worker down your way. So how do we get here? You may be asking, well, the AI and sophisticated statistical methods in energy sectors, that they were not needed like 200 years ago in 19th century. So why do we need them right now? Just to imagine the situation 100 years ago, there were typically a power plant burning fossil fuels, lighting up the streets. There was no complexity whatsoever. The city was alone, not connected with other cities or other countries. Now the situation is completely, radically different. So we are heavily interconnected. There are many and many different sources of energy, and we need to somehow deal with this. And to deal with it, we have traditional statistical methods, which are in use from, let's say, 90s, probably 1970. And from 1990, it is heavily used together with computers and computerization. But the amount of data is increasing exponentially every year. So those statistical methods are basically right now at their limits. So we need to move further. And we need to move to artificial intelligence. When talking about artificial intelligence, there are several descriptions of this field. In each and every book, you will find a scientific explanation what the artificial intelligence is. But I like the original Turing definition and the modern definition of AI. So let's read it briefly. Turing definition of AI, where Turing says that system that thinks like humans and system that acts like humans is an artificial intelligence. So just based on this premise, we have already achieved that. But that's not true, of course, because if you nowadays chat with ChatGPT, you would say, this is the artificial intelligence, this is the new human. That's not the case here. So we have somehow moved that idea further. And now we say that the modern definition of AI is that system that thinks highly rationally, even exceeding human, and system that acts highly rationally, again, even exceeding humans. And just one brief note that everybody is nowadays speaking about ChatGPT. It's a common theme here in this conference. But I think we are still, if you take a look on that lower part of the image, we are still in the first phase with artificial narrow intelligence, even with this complex neural network like ChatGPT. It will take us some time to get to the artificial general intelligence and probably decades to get to artificial super intelligence, which can improve itself and basically will not need human interaction so much. So in energy sector, we are developing mainly artificial narrow intelligences. So what is the modern approach in energy sector when using AI? Of course, we use neural networks, deep neural networks, and mainly recurrent neural networks. Even if we are right now shifting from recurrent networks, you see that loop in the picture, meaning there is some feedback from the output layer, from the outputs we have predicted in a previous step, back to the neural brain itself for the prediction in the next step. So this is our daily bread when computing an outputs for many of those topics I've mentioned. And what is not clear from this image is that main part of work is the first step, just how to prepare correctly the input layer. Meaning that you can imagine you have in your home, you have many electrical appliances. There are many homes in your city. We just got those information from the city. This is for example, consumption, and I will mainly talk about consumption here. But when we got those information, those are just a rough information. We need to filter them. We need to prepare them in a correct way, together with many other input parameters for the artificial neural network to somehow please the algorithm which trains that neural brain to get the proper outputs. So 80% of work we do is just by preparing the data, that huge amount of data for a neural network. Then there is the funny part. This is to construct the neural brain, because we are constructing it in a way, and I will say it openly, it's just reading most recent scientific papers, putting it together, and then it is trial and error. Yeah, that's the state of the art right now. So this is the most funny part, because when you design the brain the wrong way, you obviously get the wrong answers, or it memorizes the thing, but it is not capable to predict anything meaningful. So this all is possible because we have a lot of data nowadays. It was not the case in the past, but the exponential growth and the IoT world means that we are receiving data which we are no longer able and capable to process using traditional statistical methods. So to get more precise in all of those fields, I mean in forecasting of commodity prices, in forecasting of maintenance need in geographic information systems, for example, those guys who operate distribution systems, distribution networks, they need to know if there is broken pipe or a pipe which will break, for example, gas pipe leading to your home, which will break in a matter of, let's say, months or years, and there is a need to repair it right now to prevent further damages. And of course, in production and consumption of electricity and gas, we have nowadays much more data than we had before. Therefore, the logical assumption is that we should be able to predict that consumption and production of electricity much more precisely, driving the price of a commodity down. So let me tell you more about the consumption prediction here. For this case, you may imagine there are several inputs, and it is hard to prepare those inputs just for artificial intelligence. It is as well somehow hard to prepare them for a traditional statistical approach. But for artificial intelligence, it's even more trickier in many parts. we are reusing those which we can reuse from the statistical approach, because at the moment, probably I didn't mention that, that's a critical part, we are delivering software equipped with that statistical analysis for a lot of traders in Central Europe. And we still use statistical approach, but behind the scenes, and I'm revealing it right now, we are working on a different way, much modern way, involving deep neural networks. So let me show you at least the glimpses, what we do, how we do it. So as you can imagine, there are several very important inputs when predicting consumption. One of the most important is weather forecast. So if we just plan to predict what will be the electricity consumption of a city or of a part of the city, we need quite precise weather prediction for, let's say, at least next 48 hours, but probably more. Then we need to have information from DSO's previous usage of the network and from traders' previous usage of the network, which means what was the consumption during the same period over the past several years. And we have those data. We have those data for virtually each and every point, withdrawing point in the network. Then we need to have information about planned maintenances, just to avoid mistakes in those predictions, and many other input parameters. And we have to process all of those parameters the way so we please artificial network, and it will produce a meaningful result for us. So with weather, you would say, well, if you have a weather over a year or over years, you should use that weather as a marker, as something what is already known, and put it directly into the artificial intelligence. But that's not the case. We need to at least normalize it and make some other filtering on top of that weather. And by weather, I don't mean a temperature. You right now see only a temperature charts from different points in Czech Republic. We have them all over the place, over the Europe. And we do not use only a temperature, but we use as well clouds, wind speed, wind direction, and many other. Then there is one tricky part, how to explain to the neural network the concept, the notion of time. Because a neural network does not know anything about our perceiving of seasons during a year. And you may already assume that in summer there is much less consumption, for example, of gas. And nowadays, much higher consumption of electricity because of air conditioning systems running all the day. During winter, it is quite opposite. Everybody still nowadays is burning gas. So, we need somehow to tell artificial intelligence what a date in the year we are at right now. And we need to tell the artificial intelligence something more about daylight saving hours, because still in Europe we use a daylight saving hour, and it makes quite a mess, especially around those days where the hour shifts from winter time to the summertime and vice versa. So those are basically three signals we give artificial intelligence to say it, what the date is, what the date of year it is, and what should we, what are we expecting for the artificial intelligence, for deep neural network to predict. Then we need to somehow tell the artificial intelligence what part of a day it is. If it is a midnight, or if we are reaching morning hours, and so on. So we do not use traditional approach like anybody else, but we still stick with those sine and cosine wave just to interpret the hour of a day, to give it some periodicity. And this really pleases the AI we are building quite a lot. Then there is another problem, how to represent holidays, just a calendar of some country, typically Czech Republic. I here have the calendar from Czech Republic. So how to tell artificial intelligence that a holiday is approaching? And we have developed a special method. We need to give that information to artificial intelligence beforehand, again with this specialized curves. So what are the results we have when we are working on this side project for a consumption? And it is no longer a side project because this is something we are capable and able to release to our customers. We will talk about it later on. So we have already solutions utilizing traditional statistical methods. We know what the errors of those predictions are. And now we are building sophisticated deep neural network, which is capable to do the same thing and probably even better. And right now, after, let's say, a year or 2 years of research, we are capable to be in par. So that means we have achieved almost, and in many cases exceeded, the capabilities of the statistical models which we have in development and we have delivered to our customers for like last 2 decades. So this is how quickly this new technology is disrupting markets. When you take a look on the number of trainable parameters, you will see it's only 1.5 millions of trainable parameters, which is compared, for example, to ChatGPT-3, which has, I think, around 100 billions of trainable parameters. It's like nothing, but still, this is a very narrow deep neural net, which is focused mainly on consumption prediction in this case. And it seems it is enough. So the problems we are encountering. Main problem, as you may have guessed correctly, is the weather forecast. Weather is a complex system. It is a chaotic system. And I do not think, personally, that we will be ever able to predict midterm or long-term weather forecast accurately. I think we are capable of doing so during for the next 48 or 72 hours. But to have a precise weather forecast for next 1 or 2 months, it's simply impossible. So we need to stick with somehow regularized, normalized weather, which we have in our systems for longer predictions. For a short prediction, there is quite a high accuracy, as well powered by an artificial neural net. Then there are other problems, those that we are simply not capable of predicting. That's a COVID. Nobody expected in 2019 that there will be, 2020, that there will be such a huge disaster like a COVID-19. Nobody expected the war in Ukraine. And those are events which disturb the industry so much that that the predictions we've made are just useless, and we need to start from scratch using traditional statistical methods, but not that is something which will not happen in such a way, in such a for such a large period, because to adapt to COVID-19, we've spent more than a year, almost a year and a half, to just fix our predictions based on statistical model. But if we were using during that time artificial intelligence and models built on top of it, then I think that period would be much, much shorter. And then there is the third big problem, which is impenetrability. And that is probably the most significant with our customers and basically with anybody. We work and we tend to convince to use our neural models, neural networks, because we still see that in energy sector those traders are very conservative. They think that the traditional statistical methods are correct, they should stick with them, and at the moment there is no need to move to deep neural networks. But as we saw already with COVID-19, their reasoning, I think, is not accurate. We should have done much better if we were using deep neural nets there. So the problem here is that we are not capable of easily explaining why the deep neural network came up with a solution which is obviously wrong. We are capable to fix it by augmenting of input data and just writing the test cases for that particular example which is not correct, and to fix the deep neural network during a training process by those augmented data. So there is one thing which is worth mentioning, and I would like to the colleagues here to play the video, but shortly, let me describe what is in that video. It is most recent video from 60 minutes, and there is this fundamental question for a Google CEO, which asked the moderator asked the Google CEO if he is afraid, basically afraid of releasing the new, very complex artificial intelligence, even if he don't know what it's actually doing. So let us play the video. Can we do it? Should I do it?
There is an aspect of this which we call, all of us in the field call it as a black box. You don't fully understand, and you can't quite tell why it said this or why it got wrong. We have some ideas, and our ability to understand this gets better over time, but that's where the state of the art is.
You don't fully understand how it works, and yet you've turned it loose on society?
Yeah, let me put it this way. I don't think we fully understand how a human mind works either.
And that's exactly it. We don't know how it works deep down, but we know that the outcome is correct. And therefore, if we can test it that way, this is the same approach as we test humans and human brains, we should not be afraid of using it. If Google is not afraid of using it, if Microsoft is not afraid of using it, we shouldn't be afraid either. So here are briefly described the pros and cons of statistical methods and deep neural networks. And let me finish the presentation with this word. In Unicorn, we are aware of where the industry is leading. We are working on incorporating deep neural nets in basically all of our products. Right now, we have it already in Lancelot Forecast Management System, and it is coming to all of other products as well.
Okay, thank you very much for your presentation. It was very nice to see that the energy market actually does need it, right? Because it will solve many problems. I actually want to start with one question, because it was nice that as the calendar was divided into Monday and the weekends and some holidays, are you working with the idea to potentially in future predict some anomalies or some sort of, I wouldn't say extreme events because it would like lead to COVID and stuff like that I don't want. But I mean that, okay, this Monday started severely. That's it.
Yeah, there is an approach which we have already tested with a residual neural networks. So we are training several neural networks on top of each other First, we just train the big one, which predicts the standard outcome. And if we detect in a historical data some anomalies, then there is another neural network which simply deals with it, and it predicts that there is an anomaly. So this is our approach, how we do it.
Okay.
Okay. So this creates a huge opportunity when balancing the consumption and the flow of energy, because, for example, those public holidays are valid for Czech Republic, then there are public holidays for Slovakia, Germany, and so on. So that's the first part of the story, and then there is another part which relates to the way how we live, how we behave, and this creates the opportunity and flexibility. So could you elaborate it a little bit more about this topic? Because it is essentially something which where the added value is still somehow hidden, because we know that there is something like this, that we know that we want to use it, and that we want to get the added value from it. But the question is how?
Yeah. So let me put it this way. We are just starting to see those emerging properties, not only with flexibility, but as well with home energy storages, which are growing nowadays, because each and every household wants to have their own battery. They want to have their own batteries at home. And again, as this trend will rise, and it is rising exponentially, it will be harder and harder for traditional methods to predict when those people will start to using their own home storages, their own batteries. And again, here we can leverage and utilize artificial intelligence, I think, much more than traditional statistical
approach. Yes. Okay.
And just by your experience, are these energy, the companies at the energy sector investing a lot in this AI and others?
Yeah. What we know is that everybody is researching it. There are the companies, traders, TSOs, they are just playing with it, but not using it. They are, well, let's say, very conservative, and they stick with their current approach, even if they have better outcomes, slightly better outcomes from those neural networks they have developed. And one more thing. Just to imagine, go with accuracy from like 50 to 98%, it takes you some amount of work. But to get from 98 to 99%, it gets you 10 times that amount of work if you use a traditional approach. But if you use artificial intelligence, namely deep neural networks, then it's much shorter time.
It's a very common problem in all tasks.
Yes, but on the other hand, I can understand the concerns regarding the usage of neural networks in energy markets, because you know, everybody wants to be sure that the electricity is flowing the right way, and that there are not that there are no accidents and so on. So from this point of view, it could be just a matter of the time and the way how the technology is maturing somehow.
Very good. I think we are almost out of the time, so thank you very much for a great presentation and for contribution.
For having me. Yeah.
And I think again, both speakers of this block, we are before a break, and so that I remind you again to join our prize hunt, because you can answer a few questions during the break, and you know, following your answer, you could win the prize for before the next pause, before the next break. Sorry. So just follow the reference, and we can see each other in like 15 minutes after the break. Thank you.
Thank you.
Unicorn univerzity jsem se rozhodl studovat kvůli tomu, že se mi tam hrozně líbilo, zejména na radně otevřených dveří, kde bylo možnost si prohlídnout školu, myslím teda prostory školy, popovídat si se studenty, popovídat si s vyučujícími. A taky teda u mě hrálo velkou roli to, že jsem hledal školu, kde se to IT budu moct učit úplně od začátku, protože do té doby jsem s tím moc velkou zkušenost neměl, například ze střední nebo tak. Za mě nejzajímavější byly víkendové workshopy. Kdykoliv se mě někdo zeptá, čím se ta škola liší od ostatních, tak jsem poukazoval na to, že jednou za čas nás vyslali na nějaký hotel, kde nám v pátek dali zadání. Přes víkend jsme na ně makali, v neděli jsme to odprezentovali nějaké komisi, která se skládala z lidí z praxe, z lidí z akademické sféry. A v rámci těch workshopů jsme se naučili zejména pracovat v týmu, což z pohledu jako praktické výuky na jiných školách úplně často teda nevidím. V rámci těch projektů bylo vždycky potřeba si na začátku rozhodit role, kdo za co v tom týmu bude zodpovědný, to se potom držet. A nikdy to nebylo o tom, že by si každý jel svoje, vždycky jsme se museli domluvit na tom, kdo jak přispěje, kdo jakou část toho výstupu nebo toho projektu bude prezentovat, s jakým cílem. A to je v podstatě něco, co mě doprovází v práci jako do dneška každý den. Praxi jsem získával hned od začátku v Unicornu, kam jsem šel zpočátku jako obchodní koncipient. Mimo jiné teda na základě toho, že si mě právě z jednoho zmíněných workshopů vytáhla tehdy HR ředitelka Kačka Zahálková, nabídla mi práci. V Unicornu jsem dodnes, byť jsem mezi tím vyzkoušel i jiné společnosti, kde jsem se spoustu naučil. Zkusil jsem si jak velkou korporaci, SAS Institut, který dneska zaměstnává přes 15 000 lidí, tak malý startup o 50 lidech, ve kterém jsem měl na starosti obchod. Ale jak už jsem zmínil, vrátil jsem se tam, kde jsem začal, do Unicornu a neměnil bych. Online studijní materiály jsem využíval prakticky pořád. Bral jsem to jako jeden z největších benefitů téhle školy, protože jsem si díky tomu nemusel kupovat žádné knížky. Ne, že bych neměl rád knížky, ale přišly zbytečně těžký, náročný na logistiku. Ve skriptech, které byly k dispozici online, jsme našli vždycky všechno, co se následně probíralo, nebo z čeho jsme byli následně zkoušení. Stejně tak jsem se z toho připravoval na státnice. Nic mi tam nechybělo. Studium na Unicorn univerzity doporučuji zejména kvůli tomu, že to člověka naučí pracovat, že to člověka naučí dělat ty věci tak, jak se potom reálně ve skutečnosti musí dělat. Není to žádná teorie, je to prostě realita. V některých ohledech to může být trošku tvrdší, protože to vyžaduje víc než jenom číst. Na druhou stranu člověk je potom mnohem připravenější do praxe a co se týče uplatnění a hledání práce, tak pro mě to vlastně nikdy nebyl žádný problém. Já jsem spíš měl těch nabídek mnohem víc, než bych potřeboval a to samý vnímám i už je bývalých spolužáků. A obecně bych tu školu doporučil zejména kvůli jejímu praktickému přístupu k výuce, což vnímám jako největší benefit a zároveň rozdíl od ostatních škol, který znám.
Electromobility is rapidly becoming a more mainstream part of our lives. With this shift comes a rising demand for charging infrastructure. Cities, governments and companies need to ensure their electromobility development is up to the task.
However, operating charging infrastructure is a complex task. It starts with securing the connection to the electricity grid and ends with the correct billing of your customers.
Our solution is ChargeUp. We help charging station operators, private companies and governments to unify and standardize the management of large-scale charging infrastructure. It can all be sorted with a single app, ChargeUp. Everyone who charges at your location can simply use it, while you can monetize and manage your e-mobility investments. Our system will ensure a smooth charging experience for your drivers, making them happy clients who will return to your chargers.
ChargeUp makes the whole process as comfortable as possible. You can manage your stations and those of your partners all from one place. We'll also take care of the connections to the other systems, user support, and charging infrastructure if needed. The service consists of two applications, ChargeUp CPO and ESP. ChargeUp CPO is a system for charging station operators, and ChargeUp ESP provides seamless charging for the drivers.
ChargeUp CPO is a complex cloud solution for charging infrastructure operators, providing comprehensive and efficient management of charging stations. It also provides you with access to up-to-date financial and operational statistics. It allows you to operate a charging station network from a single location anywhere in the world. A single control system can be used for the management of all stations. The ChargeUp CPO maximizes the uptime of stations and helps to prevent outages by addressing them promptly. A proactive notification system will alert you about any problem, allowing the dispatchers to fix it even before the driver notices it. ChargeUp allows you to add a sub-operator to your network to create a hierarchy. This function means you can have visibility over the entire charging infrastructure on your territory. Moreover, by offering your partners to operate and manage their infrastructure via ChargeUp, you increase the value of investments when installing charging stations. ChargeUp is delivered as a cloud service but can be run within your environment too. It all depends on your needs and requirements.
ChargeUp ESP is a simple and easy-to-use application for drivers. It provides instant access to a network of charging stations through a QR code or a map and allows drivers to charge their car in a few clicks. Registered users gain additional benefits. For example, they can store their credit card, view charging history, or enter a connection with an RFID card. The customer then can use the app as a virtual charging card thanks to this connection. The ChargeUp solution also includes a payment gateway, and we are also ready to provide payment processing and correct billing on your behalf. What's more, you can integrate your branding and fit it to your needs. We can update the application's color schemes, logos, notifications, and other elements according to your preferences. Language localization is easily achievable as well.
Our 24/7 e-mobility help desk is ready to assist operators, dispatchers, and network administrators day and night. We also provide direct support to drivers and many other services related to operating the charging infrastructure. Drive with us towards the future with electromobility.
Když jsem nastupoval na Unicorn University, tak si musím přiznat, že jsem měl trošku předsudky, protože jsem si vždycky soukromou školu představoval jako školu, kde člověk nemusí moc dělat, zaplatí si to a tak říkajíc má ten titul jistý. A velmi mile mě překvapilo právě, že ta škola je velmi zaměřená na praxi, chce vlastně ty lidi ty věci naučit, ne nazpaměť, ale aby je pochopili ty věci, což vnímám jako důležitou přidanou hodnotu. A díky tomu se mi ty předsudky úplně jako zbořily, když to tak řeknu. Ve společnosti Itom Digital jsem od roku 2015, kdy jsem nastupoval na obchodní pozici a zaměřenou na online řešení. A potom jsme s kolegou dali dohromady takový přístup k práci právě, kterému říkáme vstupní studie projektu, což je příprava. toho zadání a vlastně díky tomuhle jsme se hodně na tom trhu vyprofilovali. Ta firma začala růst, dělali jsme větší projekty a klienty. Ze mě se postupně během let stal vlastně account director, což je něco podobného jako obchodní ředitel, ale zároveň ještě připravuju ty projekty a dostali jsme se k opravdu velkým značkám nejenom z Česka, ale i ze zahraničí. Unicorn University mě na práci v oboru připravila, si myslím, velmi dobře. Velkou výhodou Unicorn University je právě projektově zaměřená výuka, protože je to úplně jiný přístup, než jsem slyšel, že je na jiných školách. Pro mě osobně to mělo velký přínos v tom, že vlastně jsme řešili praktické věci, řešili jsme věci s lidmi z praxe, naučili jsme se vlastně pracovat v týmu a zároveň odprezentovat to řešení a celkově tady to zaměřené na ty projekty společně s těma workshopama, tak si myslím, že do té praxe mělo jako velký přínos. A tam jsem vlastně pochopil, že když člověk se učí od lidí z praxe a zároveň ty vědomosti se snaží rovnou aplikovat, tak vlastně má neomezený potenciál, když to tak řeknu. Za mě bych studium na Unicorn University doporučil každému, kdo chce, aby se k němu choval jako k individualitě, a zároveň, aby se dostal k zajímavým lidem z praxe a mohl si vyzkoušet ty věci rovnou zažít, ať už na těch workshopech nebo právě při té praxi při škole.
V Unicornu vyrábíme software, ale nemusíš být přímo IT specialista, aby si se stal důležitou součástí firmy.
Máme tu partu, někdy občas bláznivých ajťáků a hledáme do týmu další fajn holky a kluky.
Potřebujeme nové spolupracovníky, kolegy a kolegyně, aby naše ajťácké nápady a myšlenky proměnily v řešení a produkty, kterým budou všichni rozumět a s nadšením je používat.
Proto, abyste poznali, co a jak, musíte projít vším od začátku, podobně jako kdysi třeba u Bati.
Začneš na recepci, kde budeš zajišťovat chod našich vývojových center a třeba taky dělat support ve školícím centru Hřebečníky.
Tady máš tu kartičku. Od začátku se tak dostaneš do centra dění a hodně se toho naučíš.
Potkaj zajímavé lidi z Unicornu, naučíš se, jak spolupracujeme, seznámíš se se standardy naší komunikace a naším interním komunikačním systémem.
Skrátka poznáš, ako to funguje vo veľkej firme, kde je vo všetkom poriadok a prehľad. A tiež zistíš, že naše heslo práca hrou nie je len prázdnou frázou.
Z recepce se brzy posuneš do některého z našich týmů, kde získané zkušenosti maximálně zužitkuješ.
Čeká na tebe spousta kariérních příležitostí v marketingu, v HR, řízení a koordinaci jednotek nebo třeba ve financích. Budeš se dál také vzdělávat, rozvíjet a kariérně růst.
Staneš se součástí týmů, které pracují na těch nejlepších produktech a projektech na světě a pomáhají tak milionům lidí.
Mnoho z nás ustartovalo svou kariéru právě takto, tak neváhej a pojď do toho s námi.
Rozhodl jsem se studovat na Unicornu z jednoho prostého důvodu, doteďka si ho pamatuju, a to bylo, když jsem hledal vysokou školu a vlastně kam budu pokračovat po 8letém Gimplu, který jsem studoval tady v Sedlčanech, a tak jsem odjel do Austrálie, tam jsem strávil rok, kde jsem studoval.
So hello to the very last block of our conference, and we will start with drawing the prize that we have not been able due to some technical problems before the break. So let me ask for starting the drawing. Okay. So those of you who last but one break answer the question could be the winner of this drawing. So we are again selecting the very same process that I have described before, so shooting away those that were not that lucky, and only one remain. This is a visual interpretation of the random choice of the person. Okay, so we have a winner quite quickly. Again, I remind you that you have been contacted, or you will be contacted by our staff, and you will negotiate the price. And if you want the next prize, again, answer a quick question during our lectures. Here is the reference or the QR code. And so in the end of this block, we will again have the next drawing. And so you can be the winner of the, by the way, it's Lego car. It's not the usual car, but that doesn't matter that much. Okay, so we will start with a very interesting topic now. And it's even better because the presenter will be Marek Šťastný, my colleague over here. But he had the presentation with his colleague Filip Zoubek, who cannot be here today. So we actually pre-recorded this presentation. So we will put it online, this recording of the presentation. But Marek is here, so all the questions can be answered online. So do not hesitate to put them in, and we can answer based on what you want to know. So I will ask to run the recording of the presentation.
Hello, my name is Marek Šťastný, and I work at Unicorn as Product Hub Director. And we are here together with Filip Zoubek, our data scientist and AI specialist. Hello, everybody. To show you how we use AI to improve cybersecurity here in Unicorn. Unicorn delivers its products using +4U Internet Service, which is a digital world full of on-click products and services available for companies, organizations, and individuals. More than 375,000 users can benefit from added value delivered by solutions and digital content. Unicorn provides its solution and digital content using +4U Net service 24/7. This is the standard way how Unicorn delivers information systems, digital world products, and, for example, products supporting and enabling Education 4.0. Digital content is available on +4U Stream. So you can see the product portfolio is pretty wide. So we operate beside each other. ChargeUp as EV charging solution, Educate as the school information system for Education 4.0, and, for example, Strategy for green energy markets. All of this we provide by keeping and following highest security standards. And this way, you can imagine how complex such ecosystem could be, and how we need to face and deal with some challenges. From challenges point of view, we need to deal with solution covering various domains, operated in multi-cloud hybrid environments, with specific security, performance, and availability requirements, including hardware integration, for example, for 4,000 charging stations for EU ChargeUp, IoT, and other services provided, for example, by our partners. And all of this for wide audience, including end users, developers, testers, and, for example, automation. As you can see on the screen, the platform processes daily 37 million requests, manages over petabyte of persisted data, and all of this including almost 4,000 virtual machines. So from security point of view, this is a really complex and variable environment. And you can imagine that looking for some cybersecurity solution which could help us to improve the security generally is almost mission impossible. We tried many of them, like, for example, commercial F5, Darktrace, open source, mod security, and others. almost all of them failed in some part because they were not able to manage such a complex and variable environment. So we decided that we need to change the approach, that we need to do something a little bit different, because what we found out is that we are just one of few companies operating such a platform like we have in Plus4U.net. So this was the time when AI got involved, because we found out that AI could be perfect fit to our needs. uCloud threat detection, and the basic idea behind uCloud threat detection is that it analyzes incoming traffic and classifies particular requests by already known threats and tries to identify and help us notify about yet unknown threats. Threat detection model and uCloud threat detection is involved in a chain of components delivering particular requests to the target endpoints, and this way creates additional security layer. It works the way that threat detection is looking on each of incoming requests. It also monitors the incoming IP or the source IP. It also looks for some trends, and this way enables not just identification of possible vulnerabilities and threats coming to our platform, but also enables identification of, for example, behavioral and volumetric threats. So the main benefit here in threat detection of using machine learning is that instead of describing and writing huge amounts of deterministic rules, we are able to take and apply natural process by teaching AI to understand already existing threats, and on the other hand, to let it look for hidden connections, to try to find new yet unknown or previously unknown threats. All of this, of course, requires human supervision, because in the end it is still the statistical work with numbers and probabilities. So and all of this needs to be correctly interpreted. So Filip Zoubek, our AI specialist, will show you what we achieved and how.
Thank you, Marek. Our task is basically binary classification. This means that the output of the machine learning model must be whether the request contains some malicious code or not. That's the questions we want the model to answer. We used deep learning to construct the model utilizing TensorFlow, which is a library for machine learning and artificial intelligence by Google. And it therefore consists of multiple layers where the input is selected parameters from the incoming HTTP request. As the requests are in the form of text, our first layer is text vectorization. This layer has the task of mapping the input text into numeric form, since the other layers can work only with some numeric forms of data. Vectorization standardizes the text and split it into tokens. which are words or n-grams, as you can see in the example, in the figure below, the structure of the network. These are then mapped into the unique indexes assigned to them. So we thus created a dictionary consisting of 100,000 unique tokens during the training. The next layer is embedding, which maps these indexes from the previous layer into trainable vectors of fixed size. Thanks to this step, the model is able to find out what weight each token has, but also what are the links between them. The vectors, which are also computed during training, serves as the input to the next layer called long short-term memory, or LSTM. It is basically a collection of connected neurons with weights that interact with each other and have extra feedback connection as well. Thus, it is included in the class of recurrent neural networks. As I mentioned at the beginning, our task is a binary classification, and hence the last layer, named densely connected, has only one neuron and returns a number value between 0 and 1, inclusive, which means that the probability after multiplying by 100 if the request contains any malicious code. So if the model assigns 0 to the incoming request, the model thinks that it contains no threat, and vice versa. In our example, there is a malicious code. So the model predicted a probability of more than 99% that it is a threat. I described the general structure of the network, but it is clear that the model had to be first trained on large amount of labeled data before it could be used in production to get predictions. The training data contained more than 1 million records with valid requests, as well as with many types of already known attacks. Threat detection is not only about the machine learning model, but it is a process consisting of many steps. Let's now take a closer look at them. Firstly, the described model actively analyzes incoming requests and tries to label them, which means that it assigns them a probability if they contain some malicious code. The output of the model is logged and then collected in the log store. We then periodically process these logs by reducing the amount of duplicates and trying to extract malicious code from the labeled requests. With these steps, we are trying to simplify the work with them, as otherwise we would have to search through a large number of requests, like millions of them. The next step is data analysis and decision making. In this step, security analysts check the detected and extract threats, and they need to decide and confirm if the particular request contains some real malicious code for our services, and if so, they have to quickly react and make some decisions. These decisions can be of different types. It can be a configuration change or on the web firewall, dependency changes in the applications, or blocking certain IP addresses. The applications of these decisions are part of the next threat mitigation step. However, as the model doesn't evaluate the request correctly every time, and the malicious code are evolving, it is necessary to continuously improve the model. This is a part of the second branch in which we train the new machine learning model from original and newly labeled data and subsequently deploy it. So we are gradually expanding our data set of valid and malicious requests. And with this last step, the cycle is closed. On the next slide, I would like to discuss about data analysis and decision making in more detail, as it is a quite complex task. As I already mentioned, the output of the model are requests with threat probabilities. Based on the set threshold, which can be, for example, 50% of model confidence, we divide the collected data into valid and malicious requests. At this moment, there are 4 cases that can happen. The first case is when the model correctly predicts the malicious request, which means true positives, and thus the quickly response to the potential threats must occur as a part of threat mitigation. The second case, false positives, is when the model incorrectly evaluates the request as malicious. In other words, the model labeled the valid request with a high probability of the threat, which is unwanted behavior. In this case, the human operator must correctly label the request as valid. For the next training iteration, the same reaction must then occur in case 3, which is false negatives, if the model failed to identify some malicious code, for example, JSON-P or Java injection. The last case is true negatives, where the model correctly evaluates the requests as valid, and therefore no further action is required as this behavior is correct. To sum up, the results of this human analysis is not only in quick decisions to mitigate the threat, but also in newly labeled data, which we then combine with the already created data set that is used to train the new model. So we can say that this is supervised learning, as we train the model under our supervision. Once the model is trained, we can start with the deployment step using staging. This means that we firstly deploy the trained model on the development environment, then on the integration, and finally on the production. If at any stage we found that the model is insufficient and it has thus a worse forecasting compared to the previous one, we go back to analysis and next iteration of training. We need to investigate the conditions or circumstances under which this could have occurred and possibly adjust the input data sets or configuration of training parameters. On the next slide, you can see an example of malicious requests over time. On the right side is displayed a screenshot of the Greylog dashboard, to which we have linked the output of the model from the test environment. This solution is only temporary, but we can provide you at least a sample of active monitoring. On the top right, you can see the number of HTTP requests within the last hour, which, as I already discussed, serve as input to our model. These 1 million requests were evaluated, and it was predicted that approximately 400 of them could be potentially dangerous for us, which is shown on the bottom right. The average confidence of the model was approximately 97%. However, it should be said that this number of threats can be reduced in the threat detection process, as they may be duplicate malicious requests trying different combination of parameters or different endpoints. The potential threats must be assessed by security experts at the end. On the left side, you can see also a graph showing the input requests within the last 8 hours, aggregated within minutes. Below it, you can find a graph of detected threats within these minutes. It allows you to discover what the activity of automated bots or crackers is at the current time. It can be seen that the model detects threats within the units to tens, depending on the specific minute. In conclusion, I would like to say that our uCloud threat detection is a standard product based on the architecture. And that's all from my side.
Great, Filipe. uCloud threat detection is one of many products powered by AI, and we will add new features to it. So please, could you share with us, Filipe, what we can expect in upcoming releases?
Yes, we want to take our product to the new level by applying the learned method, especially the machine learning ones, but this time focus on the application layer. This means that we would like to identify the security risk patterns from the application logs.
So those are exciting news.
Yes.
Thank you, Filipe, and thank you all for your attention.
So thank you for a great presentation of a very interesting topic, because it's really like direct application of AI principle. Very simple to present, but I guess very hard to do in the end. Well, I have a very direct question in my mind, which is like most people in IT would think about, because people when programming stuff are usually thinking about, well, can I like generalize this stuff? Can I use it somewhere else?
Yes, we started with the implementation from the scratch. So we don't use any open source models, even those commercial ones. So we started just with the architecture, with the set of the initial data, and then we moved to the analysis and so on. So in the end, we have model and architecture which works on low-level like HTTP requests and so on, and we need to and we want to move it a little bit higher. So we want to let the AI to investigate our application logs for some suspicious behavior, and we want also to apply AI, for example, in user management, authentication, and so on, because you know, we need to move further. We need to, for example, to let the people authenticate passwordless way, because you know who should always remember and create new passwords. So those are the new fields and new business disciplines where we want to apply AI from security point of view, and you may expect those new features to be added very soon.
I believe so, because I still remember these days when the firewalls works on the very low level, and once you are able to get the request, I mean, it's not a request, it's packets or network data that is transferring. When you are on almost application level now, you can know what that. So probably it could be very high success.
Yes, it must be, because we want to provide our services the safest way available, and you know, it's all about the data. We need to provide those data secure way, and this is the approach which could definitely improve it.
By the way, that's maybe a great question, because that could be a sensitive data in your tool, or I mean, the tool should be somewhere inside the system, or how did you do this management of the data?
Yes, you heard it today that the concerns related to the ethic are serious ones, and as we will move and as we are moving to other higher levels of our services, we need to and we want to have also some ethical codexes, how to work with the data and so on, because you know, as you move to higher level, you need to understand what the people are doing there, how they behave. We, for example, can look for the IPs where the people log from, and you know, this is the kind of information which is pretty sensitive.
Yeah, of course. Unfortunately, we are out of time, or I mean, we are reaching, because we are slightly shifted. So I will end the discussion, but it's very great, because I like this simply or well-described application that you can really understand most of it. So thank you again for presenting, and thanks your colleague as well for presenting. And we will move further. Before we start next presentation, I will just remind those of you that somehow try to answer the question for the next prize, and it has been closed, that it has been open again, and you have about 10 minutes to answer again. So maybe when I will introduce our next speaker, you can again follow the QR code and the reference, answer the question, and wait for the last drawing, which will be in the end of the block.
But it's still the toy. Then.
Yeah, it's still the toy. Yeah, we haven't changed for the car,
okay.
Right?
Just to make myself sure.
Okay, so, and we will move to our next speaker. And since we heard a little that AI could be a service, you know, even from our previous speaker, we will look whether we can really use it as a service, connect to a cloud, and try to predict something on request, etc. And we have a very good guest for that, Jakub Kúdela from Microsoft, who will be presenting online and trying to tell us about all those opportunities, how you can do this online and in easy way. Can we hear each other?
Yes, I can hear you. Can you hear
that's
me?
That's great. So the floor is yours. We are so interested.
Great. Thanks for giving me the word. It's my pleasure to present here. I'll be walking through this content that I call this presentation Machine Learning as a Service. It's all about how to use the power of the cloud to consume and even build machine learning models in the new, modern cloud era. Again, my name is Jakub Kúdela. I'm Azure Go-to-Market Manager for Central and Eastern Europe, Middle East and Africa, currently at Microsoft. Prior to that, I have BI and ML experience. I worked in different BI and ML departments in banking, in energy, and even with other big tech company. So I'm all about data and analytics. This is my passion, even though right now I hold this role of Azure Go-to-Market, which is mainly business-oriented role in Azure space. So, I was thinking how to start this presentation. I believe this overview of set of services is the best one how to kick it off. I wanted to give you an overview of how we think about AI at Microsoft. The bottom part will be the focus of this presentation. So I'll mainly focus on Azure AI, set of services around specific use cases. And I want to make this very practical. So mainly I'll be walking you through demos, through specific scenarios, so you can imagine what kind of business processes and what kind of challenges you can solve with AI. But I also wanted to touch briefly our applications in the form of mostly software as a service like Microsoft 365, Dynamics 365, Bing, Windows. This is what Microsoft is well known for sure. And I wanted to show you how we're integrating AI into these SaaS applications as well. So I'll start with that. One of the use cases I wanted to share with you is this. Bear with me. Is this Viva Sales demo that unfortunately I have a trouble playing the demo. Let me skip to the other part. This one, shows you the application level use case, maybe even better. Many of you know Power BI. We are at the AI conference, so I'm sure many of you with data analytics background know Power BI. It's business intelligence tool for data visualizations, not only. And if you use this tool, usually you come to this point when you need to create, measure or KPI in this what we call DAX language. This is very much Excel-like oriented language. It's not so easy to create a KPI with this language. You need some training. But now with natural language, you can actually define what you want to achieve, what is your business goal, and this can actually create DAX for you with power of GPT. This is now possible. So you only define the metric, the KPI in business language. We return the code. You can use it right away, and you can define new measures, new KPIs in Power BI right away. So this is one of the examples I wanted to show you. How we're integrating that latest innovation in AI space into products like Power BI. coming back to Azure AI, because this is the focus of this presentation, I really wanted to walk you through some, applied AI services, what we call, around specific scenarios, whether it's, creating your own chatbot, setting up intelligent search with cognitive search service, form recognizer, indexing videos. These services are now available in our cloud and can be used right away. Even business analysts can use this because it's mostly about calling an API. We don't need, a big technical background for this. And then we have a set of services which we call cognitive services, which are all about pre-trained large models around vision, speech, language, decision, and even a set of large models from OpenAI family. This is the company that we partner with heavily. You might have read the news. So this is now integrated into Azure as first tier or tier 1 service. Let's put it that way. And then we have ML platform, which we call Azure Machine Learning, and this is all about empowering data scientists and even business analysts how to create machine learning models in code-based scenarios or even in low-code scenarios as well. So I'll start with the applied AI services. I think the best way to demonstrate the power of all these different cognitive services and applied services is with this video analyzer service that we have available. You can utilize this to actually upload a video you have. Think about lectures at your university, think about training videos at your corporation you work with or you work for. You upload these videos and we can extract metadata from these videos, like, what people are in the video, what are the topics, what are the keywords. So I wanted to show you this actually in real life, how this service looks like. So when I go here, I'm using Unicorn University video that I found publicly available. Hope you don't mind. And it's actually starring one of my colleagues, František. So, František, if you don't want to be in the video, please speak up. But I guess it's too late right now. So I'll play the video. It goes like this. It's about recruiting. It's about, career opportunities, something that František speaks about in the video. And it's in Czech language. This is what I want to stress. It's in Czech language. It can recognize the faces. You can even skip to the part of the video where the people are. It recognizes the keywords that are highlighted in the video, even labels, some of the things that appear in the video as well, and even brands like, it recognizes Microsoft as a corporation, so it put them as a brand label as well. You can even switch to timeline to really see the whole transcript of the video. So, this is just an interface, but think about it. You can get all these metadata in JSON, in programmatic way, integrated into your application. You can set up intelligent search on top of it. So imagine a scenario, with universities or with, enterprise companies, whether it's lectures or training videos. You can set up this intelligent search and you can search through, even thousands of videos. Let's say you're interested in a topic of cloud computing delivered by a specific person. It shows you the videos. It shows you even the minute and second when the topic appears by this person. You can just, skip through all of other content and get right to the topic that you're interested in. So this can be now achieved just by putting the videos into the cloud. Using this service, you can actually set up this intelligent search with your videos. So it combines several AI, approaches. It's focused on entity extraction. It's focused on how to get text from audio. So all of these services combined can achieve and enable such a scenario. So let me go back to the presentation, because I have another use case I wanted to show you, which is about extracting valuable information from forms. Think about paper-based documentation. Think about all the PDFs you have that are mostly, it's not very readable by machines. You cannot really build applications on top of this data. It's actually pretty hard, to extract information from PDF. It's not that easy, but this can be now achieved pretty easily. We have this service called Form Recognizer. So again, I got some material from Unicorn. I found this document about policy, about admissions for this year, 2022-2023, and you can see in this form, I'll zoom in so you can see it. It can actually recognize in these key value pairs that we're talking about this year. It was published in 2021. It was, signed by this this person. Look, it's not perfect. It maybe, it even shows you the level of confidence here on the right side. But the magic comes here. You can recognize even whole paragraphs, and then the result is this JSON. So you transfer the PDF or paper-based document, even you have pictures of, into this JSON format that you can then integrate into your applications, set up business processes on top of it, take actions on top of it, and it even gives you a code that you can, immediately import into your application and call this service right away. So this can now be achieved. Think about all these scenarios you can use this for. If you have thousands, millions of documents like this, you can search through it in a very easy manner. You can structure the documents and extract the information that you truly need. So this is another example of using AI in the cloud. I also wanted to spend some time on this collaboration between OpenAI and Microsoft. And, I have to say, OpenAI actually deserves the credit for, the latest innovation, including GPT that they came up with. We are partnering with them closely, as many of you know, but they are the ones who actually came up with these amazing models like, GPT, Codex, Tele. These are the models that create all the buzz in the space right now. I actually do not want to speak about prompting the GPT because you've seen the use cases in the last couple of weeks everywhere. It's it's all over the internet. I'm pretty sure you use it every day as well to help you maybe with work, with your studies. So I don't want to talk about it. What I wanted to focus on actually as part of this presentation is to give you an idea what are the limits of these models. And I believe the best way how to demonstrate this is I'll guide you to this session called Sparks of AGI, delivered by Sebastian Zoubek. Is part of Microsoft Research. Because we are collaborating with OpenAI closely, Microsoft Research actually had access to GPT for months already, even prior releasing ChatGPT before all this hype. And they were trying to basically answer this question if GPT is intelligent or not, based on the definition from psychology that, as we know intelligence right now, as it's defined. It turns out it's defined, with this ability to reason, to plan, to solve problems, to think abstractly, to comprehend complex ideas, and to learn quickly. And what Microsoft Research believes, it can actually pass through all these tests, pretty well. They think it still cannot really help us with planning. It cannot still, really learn quickly. But over time, it will get better and better. So I'm not going to spoil it to you. I'm not going to say if GPT is intelligent or not. Please watch the video. But I wanted to show you and guide you that, if you're interested in GPT and OpenAI in specific, this session is absolutely great. Instead, what I did, because as I said, they're pushing the limits of what can be done with GPT, right? This Microsoft Research. And I took several examples from this presentation because I find them super exciting. One of them that I had to take is draw a unicorn in Tixi because we're, at this unicorn conference. So I had to take unicorn example. If you do not know what Tixi is, it's a graphical language that only allows you to use these geometric shapes like, triangles, like circles. So think about it. It's actually super easy prompt. It's only five words, but the challenge is actually it's quite a challenge. To draw animal only in these shapes. I certainly couldn't do it. It would take me quite a long time, and the result would not be nice. I can guarantee that. So this is what GPT-4 actually came up with, the latest version of OpenAI GPT. Look, if you had me guess what kind of animal this is, I would probably guess it's an unicorn. I know it's not perfect; it still has a long way to go, but the fact that it was able to come up with this picture only with these thick shapes, in my mind, it's pretty extraordinary. And to show you the leap, because this is what I want to actually demonstrate, the difference between GPT-4 and GPT-3, because you don't really see that when you do, these general prompts that we use on a daily basis, like all of us, like, find me top sneakers in 2023, sort them by price, this is what I want to see. You don't really see the difference between GPT-3 and GPT-4 there. But here with this kind of challenging prompts you do. So GPT-3 came up with this, the same prompt. So I'm not sure what kind of animal this is. I wouldn't guess it's an unicorn. It's a massive difference when you think about it. Look, another example I wanted to demonstrate here is actually the creation of this game. So again, Microsoft Research, what they did with GPT-3, this is what ChatGPT runs on. They wanted to create a game where you have an avatar, you have all these attackers, attacking you, and you have some challenges to overcome. So they asked ChatGPT to actually return a bunch of code. Then it returned a bunch of code. They ran it in Visual Studio, and this is the game that came up. GPT-4 actually came up with a game that looks pretty neat, in my opinion. If I saw this on the App Store, I might have downloaded the game because it looks pretty fun. So again, it demonstrates the difference between GPT-3 and GPT-4 in my mind very well. This is about pushing the limits. This is what nowadays can be done with GPT-4. And the main difference, as Microsoft Research is showing here, is that the main difference is that GPT-4 can even come up with complex programs of over 500 lines of code. It can follow instructions precisely. And the game, the difference between the game, you can see by yourself. So it's not only GPT-3 and 4. This is what all the hype is about. But I wanted to stress that there are some really other cool models that are actually available nowadays. Codex, mainly for coders and programmers, they're well known. Maybe you have heard of this service called GitHub Copilot that helps developers to write code. This is pretty fascinating in my view. And then DALL-E, this is a service that actually takes a prompt and it generates an image. So this is AI-generated cat on the right side of the slide. And again, I want to go away from and abstract from all these general prompts that you can imagine with GPT. I want to talk about enterprise level scenarios that this can enable. I think this is super interesting when you think about it. And for that, I have actually another demo prepared for you. So let me go to this prompt playground. This is actually using GPT-4 in the background. And you can see here conversation between doctor and patient. So you give a text to the GPT, you click generate, and what it can actually generate is it can recognize the name of the doctor, it can recognize the name or the type of patient, even with ID, and it can summarize the issue they're talking about in just a couple of words, the issues with focus and memory in general. So think about this. This is very practical because suddenly it doesn't only returns text, it can actually return JSON, which can be then ingested into your, transferred into your, let's say, DocumentDB database, any JSON database that you might want to use. An application can actually take this data and maybe take some action. Maybe business process can be created on top of this. But the fact that we can now, understand the text, understand that the complex messages and interaction between doctor and patient, summarize the text, populate that into the DB, and create applications on top of it. I think it's fascinating. So, when you talk about progress with GPT, I think it's all about creating these enterprise level scenarios, or even scenarios for startups that can leverage this power of GPT. This is truly fascinating in my mind. So going back to presentation, I also wanted to show you one really cool example that helps with coding, with programming. So many of you might know COBOL. It's a very old language, I think developed in 1960. And when you read the syntax, it's actually pretty hard. So, I can do some Python, but COBOL, to understand COBOL, it's actually pretty hard. But what you can do with Visual Studio Code, with GitHub Copilot now, is to translate this code into different language, Python, and the model behind can do this in just a couple of seconds. And this is pretty fascinating to me, pretty impressive, because what used to take days or even weeks to actually transform your code from one framework to another can now be achieved in almost instantly. The code might not work perfectly. It might need some changes. It maybe needs some intervention from human, but the fact that it can simplify the translation between one framework to another, I think this fast and this with this precision, I think that's pretty impressive. So think about all these coders and programmers that used to do this, the work they usually hate, taking one code base and transforming the code to another. They can actually now invest their time into more creative tasks and some coding that actually adds value to the application, not only transforming code from one code base to another. This is mostly for reference because at Microsoft we get these questions. We want to know as a company, as your customer, what kind of capabilities and use cases we can enable with Azure OpenAI, with these large language models or other type of models in the AI space. And we have it ready. We have slide decks describing all these scenarios, from content generation to summarization to code generation, semantic search. We then get asked about this question. Okay, but I'm in a specific industry, I'm in specific vertical, I'm working in healthcare, for instance. What kind of scenarios you can enable in healthcare? And again, we have these use cases described. I'm not going over them because that would take a lot of time, but this is more for your reference. I'll try to distribute the presentation afterwards, so hopefully you can get to the presentation, or please contact me. And I can share this with you. The other question we get to ask a lot, and I think this is actually where most of the value will be coming from these models in the future. How can we take our own data, let's say our company data, and combine it with power of Azure OpenAI, meaning GPT models, but not only. And I'm not going to spend too much time on this. I only want to guide you. Maybe if you're interested in this space, please look up this GitHub repo, ChatGPT plus enterprise data with Azure OpenAI. We have samples, we have architectures describing these use cases where you can really take power of OpenAI and leverage, for instance, intelligent search on top of your own data that's sitting in databases, in files, wherever. You can take that data and run intelligent search on top of it. So this is pretty exciting use case in my view. So we spent some time talking about these specific applied AI services, cognitive services like vision, speech, language decision, OpenAI service. We covered some of them. In my last part of the presentation, I really wanted to focus on machine learning platform. Let's say you're a data scientist, you're a business analyst, you want to create your own models on top of our platform in the cloud in a fast and scalable manner. So we have this platform ready. As you might know, if you work in the data science field, training a model actually, or building a model, it's got several stages. You first need to get the data, process the data. You need to train the model with some algorithm, machine learning algorithm, and then you need to operationalize, meaning you need to deploy the service so it can be accessed by actual users. And This is usually the ML ops diagram, how it looks like. And the set of services we have available in this platform can help you with that. So certainly we have tools like, Jupyter notebooks in the cloud. We have even, Spark clusters that can really help you with the computing power. You can leverage all that if you're interested in developing, machine learning models in programmatic way with latest frameworks, whether it's Azure ML SDK, with popular Python frameworks for machine learning. It's ready, it's set up for you in the cloud. But what I actually wanted to talk about is the kind of like the step in the middle. You want to learn and start developing machine learning models, but you actually do not want to code. You only want to describe the process and define the process which you want to achieve without coding. And this is what Machine Learning Designer is for. This is a service that it's quite popular here in our Azure cloud. And I can even show you, how it looks like in real life. So you have all these predefined modules here. We're in the Designer tab. You have data available here. You have all these data transformation models like adding columns, adding rows. These are, when you're familiar with SQL, these are pretty much SQL operations in one way or another. You can do many different data transformations that can be also achieved by SQL or by Python. You have all these machine learning algorithms that you can leverage. So you don't need to write the machine learning algorithms by scratch or not even using a framework. Python, you can just drag and drop the latest, what we believe is the latest and stable version of that algorithm out there. It's managed by Microsoft, so you only leverage, the managed model or the managed algorithm definition that we have ready for you. Whether it's decision trees, whether it's linear regression, whether it's neural network regression. We can also support clustering, we can support classification, two-class, multi-class. So you decide what type of machine learning problem you want to solve. You bring that algorithm in, and you can use it right away. If that's not enough, you also have ability to write R or Python scripts on your own as part of the step in that flow. And how it looks like actually is that you start with the data. You then transform the data to the shape that you need. You select a couple of columns, you clean the missing data, you normalize the data, especially numerical values between, so they're between 0 and 1. You split the data to the training set and test set. This is, commonly done to leave that test set away so it can be actually used to evaluate the performance of the model. You train the model, you score the model. This is where inferencing is happening, and then you evaluate the model at the very end. So after this is run, this pipeline, you submit it, and after it's finished, this is how it looks like. So you have all these steps. It shows you if it went well or not, and you can actually see how the data is changing with every step, which is quite powerful. So here I'm using a data set about cars from car dealership and their prices. So we have all these attributes like, what's the model of the car, how many doors it's got, what's the body style, etc., etc. And the very last column is price. This is our target column that we're trying to predict. So think about it. If you cover this price column, you abstract from it, you take all these features that you might have available. You want to buy a new car, or you actually want to sell a new car, and you don't know how to price it. You can use all these attributes, and based on historical data, you can forecast what that price could be. So this model can be used for that, for instance. You clean the missing data, and again, with every step, you see how the data is changing here. So it's super simple to understand what's actually going on behind with this training and processing the data. You then split the data, and you get to the very last step, which is about evaluation. And remember, we used linear regression, so you have something called the root mean squared error here, which is typically used to evaluate the performance. And you then evaluate as a data scientist if this amount is it's actually good or not, but this is the error that you get, and you evaluate, hey, this model it's good enough or not. If it's not good enough, you can actually change the processing steps, you can experiment. It's all about experimentation, and what this platform allows you to do, you can experiment in a fast manner without coding knowledge, and all of the steps are actually predefined for you. You just need to experiment which one to use in order to achieve the best results. After you're done, you can click publish, and this can be actually deployed as an application in the cloud, so you can start using it right away. So this is quite powerful. So for the last part of my presentation, what I wanted to show you is a couple of resources I wanted to leave you with. So again, I'll try to distribute the presentation to those who are interested, but I also want to make sure you are aware of these resources. We have this 0 to Hero in 4 weeks with Azure AI learning opportunities. So if you're interested in that, bunch of videos and training material, aka.ms/AI learning journey. If you want to know how to consume and develop machine learning models in the cloud, this program is for you. If you wanna take it one step further and you're technical, then we have all these technical certifications ready for you with learning materials on MS Learn. It starts with Azure AI Fundamentals. It goes or proceeds with Azure AI Engineer and then Azure Data Scientist. I've done first 2. I'm now preparing for Azure Data Scientist. So if there's anyone interested to actually learn with me, let me know. We can create like a learning study group in coming weeks. And the last thing I wanted to leave you with, the last resource, is this what we call AI Business School. So for any business stakeholders out there watching this presentation, this was created in partnership with INSEAD, one of the top business schools in the world. And it shows you how AI can impact your specific industry. So it's very much verticalized by specific industries. Great content. I've gone through this. It's very well built, in my opinion. So if you're interested, Microsoft.com/AI Business School, and you can start learning right away. So that's it from my side. I hope it was valuable to you. I hope it was practical, so you could actually sense, what's going on in the AI space in the cloud. And hopefully I left you with some resources so you can continue your learning journey in the cloud. Again, I'm more than happy to discuss with any of you, if you're interested to learn more about Azure, about AI on Azure, please let me know, reach out, and I'm more than happy to get connected. So that's it from my side. I'm returning word to the studio.
So thank you for such a comprehensive description. The first question that comes to my mind is actually something that I might know the answer already, but I will ask if the AI task could be very complicated, and if you run it on the cloud, it would be like very much dependent on the resources and stuff. So how do you solve the situation if the tasks start to be very high demanding and really the resources requests are growing terribly high?
Yeah, so this is a great question, and this is what actually cloud is good for, in my view, because what you typically can do is to really leverage power of the cloud for only limited period of time. So meaning you can take a really heavy compute-intensive task that requires, for instance, machine learning model training. You can set up a cluster of VMs, or you can run it on Spark, and you can actually scale up or horizontally and run it for a couple of minutes, couple of hours, and then shut it down. So you only use the resources for limited time just to train that model, and then you can actually shut it down and not to pay for those resources anymore. So in my view, cloud can be quite powerful when it comes to machine learning, training and experimenting, because you only do it for limited. Usually, you do it for very limited time, and you don't need that resources anymore. So this scalability, up and down, horizontally, so you move from one cluster, couple of VMs, thousands of VMs. This is what can be enabled.
Okay,
thank you.
Jakube, thank you for a great presentation. This will not be a question. This will be only some stating from my side that I want to thank you. Thank you to Microsoft because we have a really strong partner here, and thanks to Microsoft we can use and leverage OpenAI, Microsoft provided models. And right now, for example, we are trying to teach and land neural network, our architecture, to make the development more effective. So there are many opportunities in front of us, and I hope that we will fulfill them and that we will follow them together, and that you will help us on this journey.
Oh, I will. I'm glad to hear that. So, you know, let's keep talking for sure.
Thank you.
So that's great to see that the chain of providing services is really functioning. So we've seen. Thank you very much for presentation. We have some time limitations, so we have jumped to our next presentation. But thank you very much to be our guest.
Thank you. Thank you for having me.
Yeah. Okay, and we will move to our final presentation because we have heard many things about how to use this, what is the principle and theoretical aspects, ethical aspects, technical aspects, etc. But we have never talked about potential teaching. We may heard some essentials about there are some requirements for the teaching system, but in the moment I will welcome our colleague Karel Šafr from Unicorn University, who will speak about, or we will discuss about the problems of how to teach AI at university level. Actually, he cannot be here, so it is again pre-recorded, so you can watch it, but I will be here to actually answer any question towards him. So I ask for recording. We have heard today a lot of presentation about machine learning, their utilization, future of the machine learning and artificial intelligence. And now is the time to talk about how to teach it, how to teach students to use and to understand the principles of machine learning and artificial intelligence. And for that, I'm happy to welcome Karel Šafr here, my colleague from Unicorn University, and ask him, so how do we teach?
Thank you so much, David, for having me. Let me introduce you my presentation. I will speak today about how we teach machine learning and artificial intelligence. So first I will introduce you our framework, how we teach artificial intelligence in our university. Then we will speak or discuss the programming languages and their context in IE education, because it's quite an interesting story. Then we will move to our courses, and I will introduce you our bachelor and master courses, which is relevant to artificial intelligence. And then we will end with 3 examples of project, what we done with our students, and that's all. That's my presentation. So some little info about me. I obtained PhD in statistics. I have quite big experience in grant research as a mathematician, and my area of expertise is mathematical and statistical methods and their implementation. So it's math combined with programming.
Okay, so I see that, and I know, of course, that you are well trained and having capabilities to teach. But it's interesting because it's not very easy to teach AI, right? So to create new experts that understand deeply what to use, when to use it. So I'm interested how it is structured. I mean, what are all the components, how they are structured together?
Yeah, that's quite an interesting story because the framework of teaching artificial intelligence is quite a complicated area. There are several problems which arise immediately after you thinking about it. The first problem is something like how to update it, because the artificial intelligence and machine learning quickly change. So we have to react immediately on the change on market and on change on internet, and teach the relevant stuff. So our courses are spread to bachelor and master degree. We have several courses in bachelor degree which are relevant to artificial intelligence. There are quite a lot of courses that are mathematical prerequisites for study this subject. We have mathematical analysis, for example, linear algebra,
which you like, and we have optimization, and then we have quite interesting course which is artificial intelligence on our bachelor degree. Then on the master degree, there is a specialization called software engineering and big data. There are several subjects. We have statistical methods in data analysis, which is statistics and machine learning. Then we have data mining, mathematics, and algorithm, and I think you will like this subject. And we have introduction to machine learning, which I teach. Then I will mention additional courses which we are preparing now. These courses will be in your accreditation, and we will speak about them later.
Okay, and when students approach for the first time, or maybe even the users of AI tools, they are starting to asking about programming languages. So what to start with? What is the best language? Yeah. So what?
Yeah, that's another quite interesting story because there's a battle between languages. It's a battle between R and Python. Especially in private sector, there are a lot of people which prefer R or which prefer Python and argue that one or other language is better. We did not decide that one language is better, and we teach both of them. And I think that's really good because each year is different. Who looks that who's won, and so we teach R and Python, but mainly on courses which looks like statistics or courses which is relevant to statistical methods. We teach R. And on courses which looks like mainly as machine learning or artificial intelligence, we teach Python. That's not because it's impossible to do machine learning or artificial intelligence in R, but that's because mainly on market and companies prefer to use Python in machine learning, and on the other side, the companies related to financial sectors and which do mainly something like regression, time series methods, the statistical stuff, they mainly use R. So in that case, we prefer to teach R because it looks more convenient in this way.
Yeah, and if we have this programming languages and we have heard about some machine learning already, and probably there will be some math, I see. So what are the prerequisites for students when entering the university and trying to teach?
Yeah, that's quite interesting. Although our primary focus is on the practical teaching of artificial intelligence, we also teach subject related to math and to the theoretical aspects of artificial intelligence. So we have on bachelor degree, we have several subjects related to, especially the mathematical analysis, which is very important to know where is the maxima, where is the minima of function. Then we have discrete mathematics, that's also very important, especially for algorithm and other stuff. Then we have statistical analysis, that's extremely important, and advanced algorithm development. That's a mathematical background for our students, how they learn the mathematical stuff related to AI. On master degree, because not all our students, especially on master degree, are from our bachelor, we have a lot of new students. So on master degree, we have applied optimization. That's the core of how to obtain the coefficient in neural network and other methods. And we have one subject which is not mentioned there, but I will have slides about them, the mathematical background for this stuff. And that's something like a review for our students, how to obtain the knowledge which they did not saw on their bachelor degree.
So, okay, so maybe that's the mathematical requirement, and I'm sure that there are mathematical courses, and we will speak about that. But let's start with something that students are happy to and they are interested in. So, what are the actual AI courses that we have?
Actual AI courses. There's the first AI course. It's on bachelor degree. That's it's called Artificial Intelligence, not surprisingly. And this course mapped the history of artificial intelligence, introduced to students what's agent, what's intelligent agents, what's intelligence, and the key concept of AI. This course is taught within the bachelor program and covers the general foundation of artificial intelligence. And by completing this course, students gain general overview of the tools and methods used in artificial intelligence. So that's something like the basic 001 course for them. Yeah.
Yeah. Okay. And so that's artificial intelligence. Is there anything more like in the components of the student? Because if we are at the bachelor degree or bachelor level, what other courses make all the components?
On bachelor level?
Yeah.
On bachelor level, there are several more courses, but they are mainly related to algorithm. And,
I see.
But we have a statistical course on our bachelor degree, which covers the basic of statistics. What they need for AI and machine learning, but just the basic. Mm-hmm. But on master degree, we have another course which is called Statistical Methods in Data Analysis, and this course is a comprehensive course on statistics for master degree, and it starts with the basic, with the basic, but with intermediate methods like regression, logistic regression, Box-Jenkins methods, the time series, the cluster analysis, discriminant, and it covers also the decision regression trees and ensemble methods. So it's a mixture of advanced statistical methods and the basic machine learning methods. And it introduced to students both this world, especially from the statistic point of view, because when we teach and when we speak about artificial intelligence, it's important to mention that it can be viewed from several angles, for several points of view. It can be viewed from IT, it can be viewed from math, and it can be viewed from the statistical point of view. And it's very important to mention the statistical machine learning.
Yes, I mean, that's maybe a good question, really, because I'm experiencing myself this when teaching math. How do you comment on for students asking, come on, I mean, I have assigned it for machine learning and artificial intelligence, I would like to program. I'm happy to learn programming languages. I'm happy to learn all the machine learning method. Why am I having this course of statistics, which is, or maybe they will actually comment on that it's old and boring. Yeah. So how would you comment on this?
Yeah. That's a general question, I think, because they like the programming courses, they like the AI courses, because it sounds cool and it makes them a little more cool. And but the statistics, statistics sounds boring, but statistics it's a background. It's a background of AI. It's a background of machine learning. And it's very important to know the basics and the background of these methods, because when we look on for example, on decision trees or on neural networks, the basic behind these methods are math, programming, and statistics. And you have to know everything from it, at least something from it, to be able to do this stuff properly. For example, you have to know how to program stuff. Because without programming, you will not be able to create neural network. But without statistical background, you will don't know how to prepare data, how to clean the data, how to find the inference which you need for converting data and transformation. That data transformation, it's a really important part of neural network. And
this may be interesting. Are you facing sometimes a situation where you show students that, okay, this problem is so specific that it's better to actually use some classical statistical method rather than big machine learning method?
Yeah. That's a real life case, because there's often some strange data sets which have some strange properties. For example, they have a really lot of columns and few rows, and for example, in this case, it's important to prepare data properly for your analysis. And we have, for example, the principal component analysis or factor analysis to create a new variable from the old, to change the dimension of the data set to something different, and to prepare it for neural network or to prepare it for support vector machines.
Okay, so that sounds cool that you combine both these. So, and what about we did have a statistic. What about the general math? I mean, what about the math?
On our master degree, there is one course which I mentioned you like it because you are teaching it, and it's data mining, mathematics, and algorithm, and that's the background of our knowledge in mathematics. And I think you will say us something.
Yeah, probably. That was a clever question because I was asking to ping pong the question to me. Well, the idea of the course, in fact, is to look at the problems of machine learning from the viewpoint of this optimization or algorithmic way. So you're going to say, okay, look, you have a particular setting, particular problem. You are well able to actually design the problem in sense of mathematical model and then to solve it. So we are trying to teach students how to design problems. So these problems then could be plugged in to solver, and the solver do the job for you. But in designing the problem, precise way that you understand everything and then you understand that all the conditions you put in are correct is not always easy, and that's what we are teaching. So we start from very simple linear programming, and we are teaching integer programming that is hard. In nonlinear programming, we are looking for the graph theoretical concept and looking for the complexity of algorithms and working with all these corresponding notions. That one of the aspect, I would say, about the math is also that something could be very long, right? You're computing. Maybe you have a big cluster, but even though you have cluster, that could be very long computation. So we are trying to teach them, okay, it's better to find a different description of the problem, and maybe your computation would be like hugely.
Okay, that's really interesting. Is it relevant to programming or to machine learning somehow?
Yeah. Well, of course, because most of what we do, I mean, from the linear algebra, from the graph theory, are small components that you can find everywhere in the machine learning, either support vector machine inside the PCA algorithm. So we are teaching the decomposition, which is the base of all these decomposition that are later used in machine learning. So everything which somehow compose the machine learning principles and models, we are trying to explain and give students their understanding of all these components. Because that's, I think, distinguish those that are just blindly using the neural network. Look, I have a neural network and use it. And those that actually understand what is happening.
Yeah,
on the data.
That really sounds interesting, and I think it's very, very relevant to what I teach on the next course, because the next course, what we will present you, is Introduction to Machine Learning, and Introduction to Machine Learning is something like our key course on machine learning on master degree. That's a course about the general machine learning. It's mainly about the neural network. That's half of the semester. It's just neural network. The first part of the semester is the background for students, the background of overfitting, overtraining, and other problems relevant and which are in machine learning. It's really key important, and it's really important, and it's really essential to explain what they cause and how they affect what they do. Then we switch on ensemble methods. Ensemble methods, for example, like decision trees, the random forest, and other stuff. Then we move to support vector machines, and I think you will like support vector machines because we teach it really deeply, and we cover how the equation in books are relevant to equation which is in programming language, because it's totally different it's a totally different story. The implementation side of support vector machines is something totally different than which is in books.
Yeah, exactly.
Yeah.
Exactly.
Then we move on to neural network world. It's a quite big world.
Yeah, sure.
And we introduce and we do with our students the basic elemental neural network. We are focusing mainly on implementing everything from scratch, just with NumPy, nothing more. Nobody needs TensorFlow for it, because we will use TensorFlow later in the semester on real-world cases. And we are doing other architectures of neural network, for example, like convolutional neural network, recurrent neural network, generative adversarial neural network, and transformer neural network. And transformers, it's it's the most popular, I think, stuff now because the chat.
Yeah, of course. Yeah. And you said that this field is developing quite quickly. Yeah. So I mean, are you designing new courses? Are there something new?
Yeah, we are designing new courses and we are changing our courses immediately. For example, the transformer wasn't there in this course 2 years ago. That's quite big new topic, and it's really popular now. And it allows students to create neural network which translate one sentence from Czech to English, and that's really magical stuff for them. And they really like it. So we add the new stuff like transformers in the last 2 years. And we are preparing some new courses. For example, we are preparing the artificial intelligence and software engines. This is a course which is about how to create agent which will do some stuff in software or do some stuff in games. Especially in games, it's really easy to explain it because it's an opponent in your games on your computer, and we are focusing on topics how to create these engines which will behave in the good way. That means intelligently, because in the past, these agents was mainly created in the way of rules, but now it's really popular to create them in the way of neural network and other methods and implement this stuff in their decision making. For example, the tactical versus strategical behavior, that's quite a big topic. We have example in the games, for example, like board games, the chess. Yeah, that's.
I mean, I can imagine that this topic could be pretty well connected with this IoT world, that you can actually program some independent agents that all together as a group could fulfill some tasks. But I mean, individually it's very simple program, but altogether it is very successful.
Altogether it changed the total behavior of a whole program and in affect widely the behavior.
Okay, so according to my experience as a student, later on I was mostly interested in programming courses that I don't know, we have a teacher, and against teacher we were programming some software and trying to beat him in a whatever game, and those who were the most successful win. And okay, do we have any projects like that? Or do we have?
Yeah, we have several projects and our students still like it.
Of course.
most fun and most essential projects. But the first project, what we teach and what we show our students, is the most important one, what changed the whole world of neural network, and it's the really popular dataset called NIST. It's the dataset with handwritten numbers, and we create with our students purely from scratch a convolutional neural network, which estimate which number is written on the image. And that does not sound so interesting, but the most interesting on this project is that we implement purely from scratch, without TensorFlow, without Keras, without PyTorch, just with an NumPy. And the students on this projects obtain the knowledge of how the parameters behave, how all this stuff works, and it's really important for them to gain this knowledge because it shaped them to.
Yeah, exactly. In this way, you can understand deeply what is happening behind, and you are not just the black box user.
Yeah.
I mean, you understand what the Google has in his box, even though it's probably slightly more complicated.
Yeah, that's really interesting. And on the internet, you will find several implementation from scratch of neural network, but this implementation with convolutional neural network,
I see.
That's I think that's a big topic for them, and they really like it.
So that's very nice because this is really the part, even you're programming robot or automatic car, you will need it definitely to read. What about the game? Because you said that
games.
there could be a game.
We have several games. For example, tic-tac-toe.
I see.
We program and we implement with our students the tic-tac-toe game in the Czech version or the general version of the tic-tac-toe, just not only with 3 rows and 3 columns. The aim of this project is to create AI player. We use for this our implementation from scratch of convolutional neural network, which gain the information from the desk of the game and transfer it from to statistical evolution of the board. And this neural network is used for evaluating the moves, which move is the best. And I will show you an example.
Oh, that's nice.
Because I will show you our implementation, what we did with our student, or what I did with our students.
So and that means that then you are playing against the player, and if the player beats you, the students get the point.
Yeah. Something like that. We did a tournament of engines.
Oh, I see. That's even better.
Whose engine won the obtained the most points?
Ah, that's very nice.
And you can now see on your computers the visual side of training. And it's training several agents now, and on each desk play 2 agents, one against other, and who loss is cancelled from the back of the agents, and the new agent is created by the evolution algorithm, by the mutating from the who wants.
Yeah, I see.
So we can look at it for several hours now.
Yeah, of course, it's very addictive.
I think I will close it. So yeah, this is our tic-tac-toe.
Yeah, okay. So this could be very nice if you program some game that is teach student that you have a particular setting and they have to follow some rules. What about some, I don't know, logistic or following cars or something?
Yeah.
Because I heard something about that.
Yeah. We implemented and we did one project with our students about something interesting about how to train a car to drive between blocks, and how to train that car to not collide and to follow predetermined path. Yeah, because there are several freely available codes which will show you how to train a car not to collide with a block. But this is something more. There is some more additional value because we have much more complicated the evaluation functions, and we add some gates which car must follow. And I have the implementation too, and I can show you some cars. Yeah, and you can see that in the first batch or in the first epoch, all cars goes randomly, and now they are starting to follow the blue gates.
Yeah, gates.
Yeah, the blue gates, and not to hit the red blocks. Yeah, some cars still hit it because it's randomly changing the coefficients. And now we have 2 cars which goes quite. Yeah.
So in real world, you will need a lot of cars to actually do it.
In real world, you will need a lot of cars and good insurance, especially if you will try to train it on parking slot.
Okay, so then the students are of course not aware of the maps you can build and you can provide.
Yeah. I think the most additional value on this course or on these projects are the thinking, how to design something, how to think about it, how to obtain a data, how to transform a data, and how to design the evolution algorithm and all the other parameters. Because the machine learning and artificial intelligence is still a world of hyperparameters, and there are dozens of hyperparameters which you have to train, and you have to predetermine and explain to users, and it's really important to know what the parameters and how to set them.
Yeah. So it's interesting. Are students often finishing their studies with some diploma thesis? I mean, with the topic of the machine learning.
Yeah. It's really popular. It's really popular. There are several. I have something like I have dozens of students who did or who do mainly the machine learning stuff. For example, the students who evaluate the photos and try to find exactly what type of car is in photo, in which condition it is, and try to set a price for the car, like to estimate the possible price. That's quite interesting. I have another student who works with X-ray scans. We try to estimate what's exactly on that scan, what does it mean, how to affect the patients, and how to interpret it. It's quite interesting stories and interesting topics.
Hey, I think we can talk on and on. I mean, it's very nice discussion, and we can continue up to night. But I think we have a limited time only. So thank you very much to discuss the teaching on the Unicorn University with me. And I hope we will see each other on the open conference again for another topic.
Thank you so much, David. Thank you for having me.
Bye.
Okay. I cannot thank myself.
Yes. Okay, thank you, David and Karel. Since Karel is not here, I would ask David. So you talked about gamification and its importance in education. So what are the other obstacles you need to, from the student point of view, you need to go over and fight with?
Yeah. That's a great question. I mean, some of the courses are very easy because, as you have seen with Karel, all those AI-based subjects are very easy. You can create a game and fight students together, etc. So that is not hard. But what could be hard was something that was mentioned as well. It is math. So some of the more mathematical-oriented, statistical-oriented courses might have some problems because you are teaching and learning as a student something which is very abstract and is very hard to somehow make a game out of it or make it funny. However, we are trying always. If there is a particular thing that, I don't know, eigenvalue decomposition or something that we have in our math, to immediately come up with something that, okay, but look, there is an application that you will need for, and once you will do this on the other course, or maybe immediately here, somewhere in between, somewhere inside this tool, there is this decomposition present. Yes. So, and then we run the simulation, then we run the transformation and say, this data has been, I don't know, transformed by PCA or other tool, but inside this tool, you can see that there is a decomposition of this data sets, etc. And then students start to be very interested in it because try to understand those things in detail. The same thing is, I don't know, we are teaching, for example, the graph theory. So immediately what we are trying to do to say, look, but there are problems in the real world. If you transform it and if you are capable of doing it, you can solve that very efficiently. However, if you don't know it and you put it to the artificial neural network without any preparation of your problem, you will fail. Because you know this.
We already saw the examples.
Yeah. So exactly. So this is how we try to motivate students to learn even some harder topics of math and statistics, because they are important, as we heard today from Josef Nový. Yes. I guess that this is important topic to know, because then you are the good engineer in AI. So we are trying to attract them and say this is really necessary because it's inside the tool and it's a good idea to understand the tool.
Yes, it's important to do it this way because the learning curve is pretty steep there.
Yes.
And we can imagine that the boring stuff related to math and statistics could be somehow overwhelming the students, and they see the results, the cars, like we saw here, and now they need to follow the path which includes those mathematical and statistical things. And on the other hand, they also need to know the programming language, like R and Python.
Exactly.
And what is your opinion on the Python and, for example, Node.js, which is our primary technology?
I know it's a very complicated question and even more complicated answer. Of course, what we are trying to teach them, it doesn't really matter what language you will learn, because that's what I'm always arguing, that now you will learn something, but believe me, in 10 years there will be something else you will be using, right? Because I started to learn on completely different languages that I'm using today. So probably if you learn Python, there will be something else like Julia, and because everyone would adopt their the language advantages, and probably the Python could be substituted, or even R, because there will be new and better languages. Maybe more popular is better to say, right?
Yes,
because sometimes it's not about a better language. So the basic idea what we are trying to do, and it has been mentioned today as well, that we are trying to learn them how to make algorithms, how to think algorithmic way to solve the problems, and the fact that in the end you will type it in R, Python, etc. is regardless. I mean, that's not important in the end. Well, there is one thing that we are trying to optimize, in fact, is that how easy are some stuff. So if you would like to, I don't know, compute with vectors and many algebraic stuff, that we turn to a specific language that everything is easy in it. If you want a more statistical thing, that again, turn to R or other languages that are more compatible or slightly better in sense of writing code for statistical tasks. Of course, it depends again, because some people are. Even the Node.js can be interesting, because I know that I have several lectures in cryptography, and in fact, because the students were not aware of any other language, or I should not presume that they are aware of other language. So we were doing cryptography in Node.js. That sounds a little crazy, but it is possible.
Yes, but on the other hand, for today's world, it means that the people should learn the basics behind the AI. Then they need to know the programming language. Then they need to know the architecture where they will program the stuff. And in the end, it creates a complex environment and ecosystem, and it's really important to help the people with this stuff, because on the other hand, they will not be effective. And if we, as much as technologies are available, we will involve in this. It will be pretty hard for them to be effective and to deliver their solutions in a shorter time.
Definitely. That's why we are teaching the Python and R in parallel, in some sense, and even the math. What I was speaking about, anything that we are describing, immediately we are showing. Okay, look, but there is a library in Python that you can use and do it. Let the computer do for you. So that's nice, because they can control whether they understand the math correctly.
Okay,
just try it. Right?
Okay.
I think
that's from my side everything.
Yes, so thank you for questions, and thank you. Thank all the presenters except myself, because I cannot think to myself. And but I hope that it was a great day. We have one duty before to saying class goodbye, because we need to choose the last winner when you were answering the question. With the car. So I will ask for a drawing application, and we will choose the last owner of the car. And I remind that it will be smaller package than you expected. It's a Lego car. It's not the real car, but still it's very, very nice, because collecting and putting it together and maybe playing with it, it could be very nice. So we will see who will be trying to put the car together and enjoy how wonderful it is. I mean, keep in mind that, you know, even collecting the car could be a relatively complex task, and you need to take care of every steps. In some sense, it's algorithmic task. So okay, so we have the winner, and again he will be informed by our staff, and the gift will be delivered as agreed with him. So that's actually the final word from me. We have enjoyed, I hope you have enjoyed already as well, the conference on artificial intelligence. We started with the general description, future prospect. We were talking about threats multiple times, and we were describing technical solution, ethical aspects. We were looking at teaching as well as improving system that exist. I think that we mostly cover everything, Marek?
Yes, it was pretty comprehensive and really exciting day today. And I'm looking forward for next conferences.
Yeah, that's great. And except the final word, I would definitely ask you for a feedback, because that we are trying to improve every time the conference for you. So definitely provide the feedback. I remind that 10 of you will obtain an online course from Unicorn Publishing and Red Monster. So do not hesitate to follow the query and also follow the reference and answer few questions about the feedback. Well, that's it. And as Marek was reminding, there will be next conference, because it's twice a year. So in November 24, there will be next conference, and I'm looking forward to see you all, or maybe meet you all that online there, and looking forward for next interesting topic that will be connected with IT. Thank you, and enjoy the weekend.
Thank you.
Which you need for converting data and transformation, that data transformation. It's a really important part of network. And also, maybe interesting. Are you facing sometimes a situation where you show students that this problem is so specific that